Huh, there we go. Look at that. We are live. Let me get this bad boy in here. This little microphone. Not too shabby. Huh? We got the sign. Alright. I think we are good to go. Well, today we're just going to be diving in, doing some 3D modeling. I know it's been a little bit of a long time since we streamed, but hey, there's no excuse for not jumping right in. So let's go ahead and hop right in. I think all we got to do is switch over to this, and here we go. Now, just to explain a little bit about what we're doing today, when you're making a DIY lightsaber, there's a lot of components that go into it, but one that is perhaps a little bit more often overlooked is having a chassis. So a chassis is something like this, right? A lightsaber chassis is what goes inside of the hilt and holds all of the electronics in the right places. Now, obviously, you don't have to have this. You could just throw your board and everything inside the hilt and hope for the best, but they tend to get a little bit battered if you do that, so it's best if you at least put some padding in there. And if you want to go overboard, which is the whole point of what we're trying to do in this series with this lightsaber, we're going a little bit overboard. If you want to go a little bit overboard, you can create a really cool looking chassis, like more along the lines of this, so that even if you open up the lightsaber, it still looks just as awesome on the inside as it did on the outside. So as you can see here, we have lots of examples of how cool these can look. I mean, some of them are even 3D printed, which is what we're going to be going for. This one right here, you can see, is 3D printed. It looks pretty sick. So what we're going to be doing today is we're going to be modeling a chassis from scratch in this video. Now, you might be wondering, Daniel, what are all of these things doing here if you're modeling this from scratch? Well, these are the things that we're going to put in the chassis, and we don't actually have everything yet, so I'll be adding a couple of things, but these are most of the things that we're going to be putting in the lightsaber. So this right here is our speaker. I can actually show you it, but basically, here you go. Well, it's not very large. Let me show you something a little larger. This one right here is our battery, right? We have this 18650 battery. So we have a few of these components. I'll link them at some point. But with these components, we can figure out where we want to place them and structure the chassis around them so that hopefully it looks awesome. That's the goal. So let me see. I think the first order of business is going to be to make sure we have all of our components, because we don't want to forget something and have to redesign the whole chassis because we didn't have all of our components. So let's go over the components we already have. We have the speaker, it's right here. We have the battery, just like this, it's right there. We have the board. Now, previously we've made some lightsabers using an Arduino board, but this lightsaber is going to be made using what's called the Profi board. And this is not too different from an Arduino board, as you can see right there, but it does have some handy features. For example, it's got this SD card slot, so we can put sounds on the SD, and then boom, the lightsaber will be able to play sounds. It also has, somewhere on here, I don't know which one of these it is, it has a gyroscope, which means it can detect how it's moving, how it's rotating. So if we want to, and we do, we can detect when it is moving very fast, and that means we're probably swinging, or when it goes from moving very fast to suddenly stopped, and that means we just hit something. So then we would play a clash sound and maybe do some clash effects. So that's what this is right here. And then we're going to want to have a couple of buttons. And these are just the standard, like, small Arduino buttons. Let me pull one of them up so you can see what I mean. Yeah, exactly, just like this. So we're going to wire those up, and that's going to be how we'll control our saber. Now, very important, if you're designing a chassis, you need to know what hilt you're going to be putting it into. So the hilt that we're going to be putting this one into is this hilt right here. As you can see, pretty awesome. This is Jaro to Paul's lightsaber from the Fallen Order games, and you can see it splits into two pieces, just like this. And you can see it is quite long. I'm going to measure the internal dimensions, and we'll put them in here so that we can figure out what kind of size our chassis is going to be. But with chassis like this, they will often have, let me get this a little closer so you can see, they will often have buttons sort of pre-built in, but they're not actually buttons, they're just sort of plungers. So right here you can see this little greebly. If we press down on it, it kind of plunges in, and you might not be able to see the inside of the hilt. Yeah, there you go. You can see it pushes down these plungers. Now there's actually two buttons, so we've got the top one and the bottom one. So what we have to do with our chassis is we have to make sure that our two buttons are aligned right underneath those plungers, so that when you press these on the outside of the hilt, it presses the buttons on the inside. So as you can see, we've got our work cut out for us. We've got a lot of components to fit in, and we're trying to make it look cool. Oh, there's one more component. This is possibly the coolest one, and it's this little lightsaber crystal. Now if you look at the bottom of this, you'll see this is actually a NeoPixel LED. So just like in the lightsaber blades, we have all of these NeoPixel LEDs going up the blade, and that's how we light it up. This crystal actually has a NeoPixel LED in the bottom of it, so it can actually light up itself. And if I pull up the listing for it, probably be a good idea, you'll see how cool it looks. Let me just, I gotta show this off. This is, I mean, whenever we get to the finished video, you'll see how awesome it looks, you know, in person. But this is the lightsaber crystal, and if we check it out, we can see there's a little video. This is what it's going to look like. So as you can see, we can set it to whatever color because it's one of those NeoPixel LEDs, and just, I mean, I think it's going to be insane. You're going to open up the lightsaber, you're going to have this crystal there glowing whatever color the blade was glowing. It's just, I think it's going to be beautiful. So that is a very important component as well, and since we haven't added it to that yet, let's go over the process of adding one of our components. Exactly. It's, I mean, it's, yeah, I can't wait to actually get this thing powered up and see how it looks in person. I think it's going to be, I think it's, yeah, this is going to be an insane lightsaber. So if we want to add a component, one of our components to this, we just start by picking a shape. Oh, if you guys don't know, by the way, this is a website called tinkercad.com. It's made by Autodesk. It's completely free. You can actually go there right now if you want to follow along. I'll link this file afterward. I'll drop it in there, and you guys can access it if I remember. If I don't, you can just comment and I'll add it. But we want to start, we have these shapes here on this side. We want to start by adding a shape that's pretty similar to our crystal. Now, it's obviously a pretty, you know, interesting shape, but we'll probably just go with a cylinder, because if you look at the bottom there, you can see it's pretty cylindrical. So we just want to measure that. If you were going for some real precision here, you might want to use calipers or something, but here I'm just going to use a ruler, and it looks like it's about 1.1 centimeters, so 11 millimeters. Looks about right. So we can just set this cylinder to be 11 millimeters by 11 millimeters. And I like to put this sides bar all the way up to the top so that it doesn't look as ugly and faceted. Of course, we could also take it down, and then maybe it would look a little bit more like the crystal, because obviously the crystal has facets. But that's not really that important. So I'm going to lay this down, because I think that's the orientation that we're going to want it in. And let me just throw it on the ground. And we can just sanity check this too if we want, like just to make sure that these components are seeming to be reasonable sizes. So if we take our Profi board, which is the same as this blue guy right here, because it's kind of blue, I don't know, it's pretty dark blue, and then we take this crystal, we can see, yeah, those seem to be about the right size for this and this. So there we go, good sanity check there. And okay, I think that is all of our components, but we also need to know the space that we are building in so that we can make sure we fit all of these things in place. And the space that we are building in is obviously this lightsaber hilt, so we just want to measure the interior dimensions of it and get a good idea of how much space we have. Okay, it's just a little bit under 3 centimeters. Let me see, it's kind of dark at the moment. 2.7, I'm going to say 2.7 centimeters, so 27 millimeters seems reasonable. So for this, I'm going to bring in a whole object, and the way that Tinkercad works, basically you can just have objects that add material and you can have objects that remove material, and you can just click this box if you wanted to switch an object to removing material. So I can just click that. Now this is removing material. So I'm gonna make this a kind of negative removing material type of thing just because it's clear and then we can kind of see through it. Now as far as the length goes, this is in 2 different parts, so they actually could be different diameters. Let me check. No, I think they're the same, 2.7 centimeters, but we do need to know the length because that's important as well, and we're also going to need to know where these plungers are, as I mentioned earlier, but we'll have to deal with that in a second. So let me figure out how to measure the length of this. Looks like it's about this much. If you don't know, if you have a thin neck hilt like this, what they tend to do is they'll narrow out the inside as well, so you can see there it gets significantly narrower. So what we'll do with this hilt is we will have all of our electronics on this side, and then we'll have just 3 wires go through here, and those wires will end up going to the blade. So for our intents and purposes tonight, the chassis cannot go past roughly about this point, because that's where it starts to get narrow. So that's all we're going to be dealing with tonight. So it looks like on this piece we have about 5.5 centimeters, about 55 millimeters of space for us. So that's going to be 55, and then remember we made this was 27, and of course it needs to be 27 wide as well. Alright, so that's the top piece here. That's just this section right here. Then we also want to go ahead and take a look at this bad boy, and it's the same inner diameter, but it's much longer, so that should give us a lot more space to work with. And it looks to be about 13 and a quarter. Yeah, so 132 roughly. 132 long. Let me just make that 132 long. There we go. Now I managed to get them lined up, but if I hadn't, if you click on multiple objects, you can press L, and then you'll be able to align them in a variety of ways. So here I want them to be on the ground, and I want them to be centered horizontally like that. Alright, so that's the space that we have to work in. Pretty cool. It does look like we're going to be able to fit everything. The important points is just getting everything into the optimal position depending on what we want it to do. So obviously the buttons, we'll get more precise in a moment, but the buttons have to be right about here. Because if you remember, if we look at the hilt, we have the plungers here and here, so the buttons are going to have to be right there. We don't really have control over that. Now, the next thing that we want to consider is what it's going to look like, right? The important thing about the chassis looking cool is that when you pop off the bottom of the hilt, when we take this part off, we want to reveal an awesome looking chassis. And I think the most awesome part is going to be this lightsaber crystal piece. So I think we probably want that to be immediately below the button section. So it's the first thing you see when you pop that bottom of the hilt off. I think that would be the best arrangement. And maybe it doesn't work out and we have to end up moving it somewhere else, but I think that would be ideal if we can actually put the crystal right there, so it's the first thing you see when you start taking it apart. Now the speaker we probably want this to be, and it's going to be rotated like this so it can fit, but we probably want this to be at the very end because there's some holes in the bottom so that sound can come out. There's obviously not any holes really in the, you know, the middle of it, in the grip or anything like that. So we want this speaker to be at the end so that the sound can come out and hopefully sound very nice. So I'm just going to take a moment to align everything. And there we go. It's starting to look good. Okay, this actually does also need to be moved in a little bit. Dink, just like that. Now I don't want to move it any horizontally on that axis, I just want to move it like that. So there we go. We've got the speaker right at the end there. Now our only two remaining components are the battery and the Profi board. Now the battery, we do want it to be in this bottom section of the hilt because that's the section that comes off. With this upper part of the hilt, we've got the buttons here and then we've got some screws on the opposing side. So what's probably going to happen is that once we put the chassis in this part, it's not going to come out. It's just going to be permanently like glued and screwed in place in there, semi-permanently I should say. So anything that we want to be able to edit or adapt or anything like that, we want it to be in this bottom section here. So the battery, obviously we want to be able to take it out so we can recharge it and change it to a different battery. So that is going to need to be in this bottom section. And it doesn't look like we have any it doesn't look like we're going to have enough space to fit the Profi board along with the battery. I also don't think, I mean, we might have enough room to squeeze it in there as well, but keep in mind we're going to try to make this look cool, so we might make some additions. So I think our safest bet is, let me just hide that for a second so I can get at the Profi board. I think our safest bet is to have the Profi board up top there, overlapped with the buttons if need be, because they're going to be pretty high. And then we can have all of these things here in the bottom section. I think this layout is looking pretty reasonable. So we're gonna have to do, we're gonna have to figure out how to get the Profi board and this in here. Oh, this is an important point. The Profi board, we do need to be able to access it because we need to be able to connect an SD card and remove the SD card if we want to add sound fonts, and we need to be able to get to this plug at the other end if we want to change the programming at all. So actually, bear with me for a moment. I was wrong about not needing to access the Profi board. So I think we can still get away with this if, keep in mind the buttons are going to be pretty high up because they need to be able to be pressed by the plungers, which are just coming down from just outside the space. And then if we take the Profi board, both of the things that we need to access, the SD card and the port, they're both on one side. Very convenient of the designers to make it that way. So all we have to be able to do is to access just this one end of the Profi board. That was not right. I think I need to move it 5 on that axis and 0 on that axis, 5 on that axis. There we go. So that end of the Profi board that's facing that way will be the end with the SD card and the port. And then, when we pop it off, we'll be basically just looking inside of here, and we'll be able to pull out the SD card or plug something into the port. Hopefully, that's what I'm thinking right now. Would be a good design. Just because I don't think that we're going to be able to fit it alongside the battery. Like, I don't think we can fit battery and Profi board next to each other in the hilt. I don't think that's going to work out. Okay, so with that in mind, we probably want to have some space for your fingers to get in because you're going to want to be editing the SD card. You're going to want to try to grab the SD card or plug into that port there. So we probably want to move the crystal down as much as we can without it running too far into the battery. So somewhere around here, and again, we're just starting with a very rough layout. Obviously, we'll get more precise later, and we'll hopefully add some cool details and stuff to make it look really nice. But I think that should be a good rough layout. Both of the buttons are in place where they can be hit by the plungers. The bottom of the Profi board here, we can access the SD card and the port. Maybe we make it stick out a little bit more too, so that it's like kind of sticking out when you remove this bottom part. we'll see. And then we have the crystal chamber, is what you see immediately when you start to take apart the lightsaber. We have the battery with some space around it for the battery holder. We might actually need to measure the battery holder and put it in. That's probably an important step. And then at the bottom we have the speaker, because the bottom is where the sound is allowed to be let out. Alright, I'm just going to align these again horizontally, so just press L, then align them horizontally like that. And I think that's looking pretty promising. Now, as I said, I did notice that we added the battery, but we forgot to include the battery holder, which obviously takes up some additional space on top of the battery. So let's go ahead and figure that out now. Because that's also going to be probably one of the more structural things. So we're going to want to make sure that our chassis is kind of built around that. So let's go ahead and hide some of this extra stuff around the battery holder, and let's figure out the dimensions of the battery holder. So lengthwise, we're looking at 7, 1, 2, it looks like 7.7 or 7.8. Let's just make it a safe bet and go with 7.8 or 78 millimeters. So we're gonna wanna, nope, that's not right. We're gonna wanna throw this down and make sure that we align it with that. Now, this is a little bit unfortunate. We have to make sure that we peer everything, so we can make sure everything is aligned, because we don't want to align the battery holder. I mean, hi, how you doing, Monica? We don't want to misalign everything. I think it's fine. Sorry, just having a little bit of confusion here. I think we can just ignore everything else, go ahead and make the battery holder assembly, and then we'll worry about putting it in place with everything else. So, to that end, let's hide everything else. Okay, so, the battery holder assembly. How do we put this together? Well, we need to align these two, and then we discovered that the battery holder was 78 millimeters long. So let's go ahead and make this 78 millimeters long. Let's go ahead and align these two. Again, L to open that up. Now, how tall is the battery holder? The battery holder is 15 millimeters tall, roughly. So let's go ahead and chop that down to 15. Now this is interesting. On the actual thing, the battery definitely sticks out, but it doesn't seem to be sticking out here. So what are we doing wrong? Oh, well, the battery can't be all the way at the bottom in the actual thing. So we will have to move the battery up. I'll figure out exactly where to move it in a second, but I just want to make sure that we can see it. Alright, so the battery should be aligned. Yeah, it looks like the battery is roughly aligned horizontally. So let's go ahead and, oh, thank you. I appreciate that. Let's make sure it's aligned horizontally. Awesome. And let's go ahead and figure out how deep it needs to be. Now, obviously, this isn't exactly a square profile or a rectangular profile. Obviously, it is a bit angled, but we don't have to be exactly perfect with this, as long as it's close enough that whatever we build around it, we'll still be able to like glue this onto. And honestly, we would probably just douse this thing in super glue and everything will hold together. So it doesn't have to be stupidly precise. Okay, so the battery seems to stick out above the top by about 4 millimeters. So let's top align this and then move the battery up exactly 4 millimeters. Okay, there we go. So now I think this should be a reasonable estimation of our battery holder. we've got the holder and the battery sticking up a little bit. Now, one thing that we've got to keep in mind is that the battery holder seems to have, and this is going to be a little bit hard to show, but there you go, some little things sticking off of the bottom. So I'm debating what to do with them, but I think the best option is probably to just cut them or sand them off, because having little stick downs like this I don't think is going to be particularly helpful. It's going to be really hard to align something as small as these little stick offs in our 3D model. So the best idea I can come up with is we just cut off these little things on the bottom, and then it'll be a good it'll just match up with this model that we've created. I could end up adjusting that, so obviously we're not going to cut them off right this second, but for now I think that'll be the plan. Now you can see this started to take up a good bit more space, but I think we still have plenty of space for everything, so let me just make sure everything is aligned like that, and then let's move the battery casing down a bit. Let's say 14.5 millimeters, just so that we have a little bit of space there. And then we want to, of course, make sure that it's down inside. Remember that this gray outside is all of the space that we have. So if anything's sticking out, that's not going to work in the real world. Okay, I am liking this. I think it's working pretty well. Now, my main concern is, like I said, we want to try to make this look really nice. And I am noticing that the battery casing is very close to the edges here. Like, we have very limited space around it. So I'm not really sure how we're going to make it look nice. Like with the crystal chamber, we have plenty of space. We can add little things around it to make it look nice. Like you can see an example of someone doing that here. With the battery thing, I'm not sure how well we're going to be able to do that. But I guess we will cross that bridge when we come to it. Now, yeah, I think the next step is we want to make sure that the buttons can end up in the right position and that the Profi board can be accessible, can have that one end accessible so that we can access the SD card and the port for reprogramming it, and the SD card, we want to access it so that we can change the sounds on it. It would be very unfortunate if we could never do that. So I think let's go ahead and place the buttons and the Profi board, and then we'll figure out how to make them look pretty as well. Okay, so for placing the buttons, we got to take a look at our hilt right here and figure out how far in each of these button spots is with our trusty, okay, not with our trusty ruler because our trusty ruler doesn't fit. Maybe we can get another ruler. There we go, found some other rulers. So hopefully one of them will be able to fit inside. I think this one looks pretty skinny. All right, let's take this skinny ruler, shove it inside, and measure blast. I really shouldn't have made it this dark. Okay, so the one screw point is really right at the bottom of this section here. But I'm realizing if we have this ruler that we can put inside, then we can actually use that to get a more accurate measurement of the length of this section, because last time we were doing it from the outside, just kind of guessing. Okay, and unfortunately this ruler is inches only. So this is 2.5 inches. This section, having measured it more precisely this time, it's 2.5 inches. So let's go ahead and show this. And this is including the little section where it screws together. So we need to, we just need to keep that in mind when replacing everything. So this is going to be 2.5 inches. Let me just switch to inches right quick. There we go. And then we can make sure that this is 2.5. Okay, wow, we were significantly underestimating, I think. Let me just double check on that, because that just got a lot longer. And I just want to be sure we're correct, that we don't make our chassis way too long and then not be able to get everything inside of it. Yeah, I mean, it really is 2.5 inches. There you go. Wow. Okay, so now that 2.5 inches doesn't include the screw section, so I'm going to make a separate, I'm going to move this down a little bit because I want to make a separate thing for the screw section. So let me just move this down 0.2 for the moment, and we'll figure out how wide that screw section is. Oh, sorry, that did include the screw section. So we actually need to cut off from this however wide the screw section is. Yeah, that's exactly the reason that I'm doing it in Tinkercad. The reason I'm doing it in Tinkercad is because literally anyone can just go to tinkercad.com at this exact instant, and they can do exactly what we're doing. Also, it makes it super easy. As long as I remember, I can just copy the link to this, put it in the description, and then you guys will be able to access it as well and see the results of all of the yammering that's been happening over the last few minutes. Okay, this screw distance looks like it's just about 1/4 inch, so I'm guessing that it is exactly 1/4 inch, because why would they make it anything else unless they're in the metric system? But it looks like it's about 1/4 inch, so let's go ahead and chop off 1/4 inch of this, make it 2.25, and there we go. So now this section right here is where the screw section is, and we want to, again, we can see, well, you guys might not be able to, but the one of these buttons, because we have these two buttons here, it is the X-Tech model. I don't know how you knew that, but it's the X-Tech model, which, as I understand it, is somewhat less common, and so there's less people making chassis for it. So this will hopefully be a win for anyone who wants to use this particular model. I'm just using it because it's cheap. So the button seems to be right at the edge of this section, so we can just go ahead and align this button with this edge. Now, absolutely, they just slap a 1-inch core plus pixel connect. Yeah, exactly. Yeah, and I mean, we will have to do a little bit of shenanigans because of the thin neck, so we'll have to put some wires through there and then solder on the, the whatever that connector is called, the PCB connector. I don't know if it has a name, but yeah, we'll have to do that because of the thin neck. But I think it'll be educational, hopefully, for anyone who wants to use a thin neck hilt, or especially if they want to use this specific hilt. It'll make it a lot easier for them. So how do we get this lined up? Because we can align it, but the problem is then it wants to move. Maybe if I just select them in a different order. No. I want it to move the button and not the other thing, but I'm not sure if there's a way to do that. So I guess we'll just have to figure out how to align it again. Let's grab all of these. Man, I don't know how we're gonna get this aligned both here and here. Let me think. Maybe if we create, let me just go ahead and duplicate this, extend this back out to 2.5 inches, shrink it down to 0.25 inches, so that's now the screw section. Then we hide this, grab this guy and this guy, and then we can just align them like this. No, that doesn't help. Blast it. Okay, we duplicate this guy, switch it to looking like this, and then we hide him. No, that's not gonna help either. Let me see. How can we get this aligned? I don't know why I'm having so much trouble with this. Maybe there's an easy way, maybe there isn't. All we need to do is, I'll just do it manually, it's fine. Just move it. We don't want to move it horizontally at all. And then we're just gonna play around with this value until we get it to be pretty good. How are we doing? This might also take a little bit of testing because we're currently working on the buttons, that we're pressing down here, and the plunger is it's going to be a little bit difficult to make sure that the plunger aligns with this part of the button that is clicky, but I think that what we want to do is we want to actually make sure that this one is sticking a little bit this way, not obviously not that much that way, but I think we want to make it a little bit sticking out that way so that the plunger comes down on top. It's going to be kind of hard for you guys to understand what I'm saying with that, not being able to actually see the way the hilt is laid out, but I think hopefully this is roughly the position that button should be in. So now we need to measure and figure out how far in this button should be, and then we'll need to figure out how high up they should be, which is going to be another challenge. Okay, so how do we figure that out? I think if we can just align our ruler with sort of the indentation that the plungers have. Okay, actually I'm aligning with the top of the plunger right now, and it seems to be pretty easy to align there. So let's, well, let me see. It is quite dark, if I haven't mentioned it yet. Okay, if we press down the plunger, then we can just put this on top of the plunger, and we can get a measurement, which is roughly 1 inch. Looks like this is about 1 inch in. But not quite. It's a little bit less, which is weird. I don't know why it's so close. Yeah, I think it's about 1 inch in. For the top, just under 1 inch in. So let's show the outline of the hilt again. And wow, I didn't realize it was sticking out that much. I think it'll work. I'm not sure. This may be a chassis that takes 2 tries. We'll have to see. The good news is the second try is usually a lot easier because you're just adjusting some little values. Okay, but from the top of this, so what we want to be the right side of this button, we want it to be 1 inch in from this line right here. How do we accomplish that? Fair question. I think we duplicate this, we make it 1 inch long. And okay, it actually can't be quite 1 inch long, and I'll show you why in a second. But we need to figure out the width of this button, which is 0.236. So now if we make this one 1.236 long, 236, then we can go ahead and yeah, there we go. Then we can go ahead and align this one with the end, and now the right side of the button will be 1 inch away from there, because the left side is 1.236 inches away from there, and it's 0.236 inches wide. Okay, those are looking very widely spaced to me. So what we can do is we can sanity check it, because we have the Profi board, which we know is this size, right here. We know it's, the 1.3 inches or whatever. So we can see, okay, is the spacing between these two buttons actually almost the length of the Profi board? And to be honest, the answer is no. The Profi board is, it's more like half, if you guys can see that. It's more like half, maybe like 3/5 of the width of the Profi board. So it seems we have made a mistake. Let me see. What have we done wrong? We can actually grab a ruler and check the distance in between these two buttons. I think we can, somehow. How do we check the distance in between these two buttons? Well, we can check the distance from the edge of one to the edge of the other. So we can see right up here, the distance from the edge of the one plunger to the edge of the other, according to this, should be about 1.2 inches. And me measuring it, it's under an inch. So we're definitely doing something wrong here. Good thing we caught that. Let's just reset back a little bit. Not that far. Let's reset back to here, because we know that this button is in the right spot. We just need to figure out how far away to put this button. Oh, thanks. Yeah. We haven't done that much so far. So hopefully we're able to make it look cool. That's what I'm most worried about. Making it functional seems like it won't be that big of a deal. We just, put some random primitive shapes here and there and figure out how we're going to glue everything together. But making it cool, that's going to be the challenge, making it look like one of these types of chassis that we've been taking a look at. Yeah, making it look like one of these, that's going to be a bit more of a challenge. Wow, that one they packed in 2 crystals. That's kind of insane. Okay, so how far away do we put that button? Let's try this again. Going from the easiest way to align it, I think, is going to be going from the right edge of this line here to the left edge of that. So let's try to get that measurement if we can. I'm going to grab this trusty ruler, go ahead and try to line it up with that. And man, it seems like we're going so far in. What if the ruler's defective? I didn't think of that. Let me check the ruler with the other ruler. There's a good plan for you. Nope, the ruler's not defective. Alright, well, it was worth a shot. Okay, so we need to figure out how far away this button is supposed to be. This is the biggest challenge of the day so far. And it really does look like almost 1 inch, like maybe an 1/8 under an inch. Let's say an 1/8 under an inch. But that is the measurement to this edge here. I think that might have been our mistake last time, is that we measured against this edge instead of this edge. This area here is the screw where the 2 sections connect to each other, so that always makes things a little bit confusing. So what we want to do is we want an 1/8 under an inch, so 7/8 of an inch from here to this side of the button. So I think what we want to do is we want to go ahead and duplicate this. Let's go ahead and make it 7/8 of an inch long, so 0.875. And then we want to make it just a bit longer because we want to align the left side of this with it. And currently 0.7, whatever it is, 7/8 is supposed to align with the right side. So this thing is 0.236 long. So let's go ahead and make our little alignment piece that we're creating here. Let's add 0.236 onto it. So 236, add it on there. Okay, I added it onto the wrong dimension. Let's try that again. 0.2, blast it. I have to go over the one. 0.2, 0.36. There we go. As long as my math is correct, we've extended it by 0.236. So now if we grab this, nope, I did not mean to hide that, and then we align it with, blast it, not with you, you chicken nugget. Okay, we grab this guy, we hide him, then we shift select this guy, we can align that, not that button, dang it, we are really struggling. Okay, we grab this guy, we hide him, we shift select this guy, so we still have the hidden guy selected, so then when we unhide him, they're both selected, and then we align them, bang, like that. Now, our spacing should be correct. So if we delete our extra spacer here, then again, we can sanity check with the Profi board, because we know how big the Profi board is, and we can see, okay, it looks like we've got, a little bit of space on the one end of the Profi board, a little bit of space on the other. And that looks much more reasonable compared to where the buttons are than it did before. I think I'm happy with that. It seems, just based on a quick sanity check, that is probably okay. Again, I'm sure some stuff will go wrong when we print it, but we can always tweak things later. Okay, so the buttons are in place. The buttons are in place horizontally wise. They're not yet in place vertically. We need to figure out how deep they should be, which may be a slightly trickier challenge. I'm not sure. So the plungers, we can see just by looking at the bottom of this, the plungers align almost exactly flush with the inside of the hilt. So that would mean they were exactly flush with the outside of this gray area, because that's what we're using to show the inside diameter of the hilt. So based on that, we can figure out how much in they go. Honestly, it doesn't really matter, as long I guess the best option would simply be to make these buttons, yikes, the best option would probably be to make these buttons simply be flush with the top of the hilt as best as we can, because then as soon as the plungers start to press, they press against the buttons, because it doesn't matter if the plungers could go too far. Obviously the plungers won't go too far because they'll hit the button. We just want to make sure that the plungers are hitting the button. So yeah, it seems like it should just be pretty straightforward. We just turn down the snapping to something much smaller, and then we can just align these bad boys with the roughly the top of the hilt. Now we want them to be a little bit inside because there's always tolerance issues, and it's always tighter and harder to get stuff. It's always hard to fit the chassis into the hilt, let's face it. So we want to make sure that we can fit it in. So I'm going to make them a little bit below, because again, the plungers go decently long. So if there's a little bit of space, the plungers should still be more than long enough to be able to press those buttons. Also, it's bothering me that these are very faceted and don't have a lot of sides. So I'm going to make them pretty for literally no reason other than, well, pretty. Okay, the buttons are in place. As far as we know, the buttons are in place. The next thing I want to tackle is where should the Profi board go? And if this is the screw section, then that means that this is open air. When we remove this piece and are left with just this piece, everything in this gray area here will be in open air. So we want to make sure that the Profi board is very accessible, that the end of it is very accessible, because that's where the SD card is, and that's where the I mean, it does allow you to provide power, but what's important is that it can be reprogrammed through this port. So we want to make sure that the SD card and that programming port are accessible, which means, I think, just making this stick out a good, healthy amount. I'm also not sure which way we want it to be rotated, whether we want the SD card to be on top or on the bottom. Also, to get a small 3D printed piece to attach to the SD for easier SD access. So like, glue something onto the SD so that we can have like a little handle. Is that what you're suggesting? To get a small 3D. Okay, yeah, no, that sounds like a good idea. I'm gonna be honest. Yeah, so if we just since chat isn't on screen, somebody suggested that we go ahead and design a little 3D printed something and put it on top of the SD, because if we made some kind of a handle for it that was significantly larger than the SD, then we could grab onto it and pull it out. I never would have thought of that, but that's actually, yeah, that's a really good idea. So again, that just means that we're going to want to make sure that this is sticking out a good, blast it, which way are we going? A good healthy amount, so that whatever handle we make is nice and accessible. Now the main reason that we want to stop it from going out is because we want the crystal chamber. We want to have plenty of room to put stuff around the crystal chamber. So I might just move it back a touch. But I think hopefully that, because this measurement of this box is actually just for the Profi board. So the SD card sticks out a bit beyond that. So we should probably go ahead and throw in a measurement for that. Hold on, let me do that. How long is the Profi board without the SD card? It is 33. Yeah, I think that's 33. 33 millimeters. Let's go ahead and switch back to millimeters, because it's just a little bit easier to measure stuff with millimeters. I am an American, but we are going to have to... Okay, yeah, this is the measurement I pulled off of Google when I didn't have access to the Profi board. So it is 33.2 is probably the exact figure. That's awesome. Then we need to figure out how far beyond that the SD card sticks out, which is approximately 3 millimeters. It's a little bit under 3 millimeters, but it's roughly 3 millimeters. So let's copy this. Well, duplicate that, then extend it by 3 millimeters so that it becomes, instead of 33, 35.2, and then we'll, I mean, we can leave it a little bit longer. I don't know how long the SD card is, doesn't really matter. What matters is how wide the SD card is, which is, looks like about 11 millimeters. So let's go ahead and make it 11 millimeters wide. I think the keybind to resize from both sides is shift. No, that's not quite right. Option. There we go. Option. Well, we need a good zoomed out view so that we can, so that we can resize this. Okay, so hold Option to resize from both sides. Then we want to make it a width of 11 millimeters. And then we also need to figure out the height. Should be pretty thin, but it looks like it's about a millimeter. So let's go ahead and make it 1 millimeter. There we go. Now we have our little SD card sticking out. Looks pretty nice. Okay, and that's how far it sticks out past the edge of the board. Now you can see there's a little bit more room that we can access that we could glue on our 3D printed handle to, but we'll worry about that later. For now, let's just, as we make the chassis, try to make enough room that we can add that potential 3D printed handle. You could also find a 3D model of the Profi board online and import that. Might be easier. That's a really good idea. I probably should have done that before. At this point, it might be too late. I don't know if they have one with the charging port. It might be good to see where that is. Actually, that also brings up a good question of whether we should have the SD card or the charging port, which side each one should be on. Let me think about this. How are we going to access both? I mean, I guess we can always take the SD card out for when we're programming it, so we should probably have the SD card be on the bottom, because we can have whatever handle be on our SD card. We can use that to unplug it, and then we should be able to get at the charging port. But I will, yeah, I think I'll do a quick check just to see if there are any 3D models of the Profi board that we can quickly import into Tinkercad, and then be able to, actually, we can also check Tinkercad's gallery. I don't know what the odds are that someone actually made one here, but we can look for Profi, just see if anything comes up. Oh, look at that. Some other people have designed chassis. I don't think any of these seem to have an actual Profi board in them, so we will have to go to the wider Google, see if we can cook something up. Not seeing something immediately. The main problem is probably not that there aren't 3D models of Profi boards online, but probably just... Oh, you found something? You can drop it in chat, I think. I don't know. It might stop you from doing links, but well, hopefully it doesn't. Let me see. Alright, I think this website is terrible. Let's see if we can find anywhere else. Yeggy. See, these index sites, like, sometimes they're very useful, but sometimes, I don't know, I question the purpose of them. Alright, that's fine. We'll do your stupid cookies. Yeah, you can send it on the Discord. That'll be perfect. Let me pull up the Discord. Sick. Let me pull this bad boy up. I think we want the STL to import it into here. Let's take a look. Profi board version 2. I'm guessing there's not a whole lot different between the version 2. We technically have the 3.9, but I believe they did work to make sure that the footprint size was the same and everything. So we should be good to just download the Profi board version 2 and then go ahead and throw that bad boy in here. and see what happens. Yeah, exactly the same. Exactly. Dude, whoever designed this bad boy and all the other Profi boards, those guys are legends. I have to say. It is a nice piece of technology. Okay, maybe it doesn't support drag and drop. Let's try this. What is it measured in? That is a good question. I'm gonna guess millimeters. Yeah, Frederick hub. That's exactly right. Alright. Yeah, Tinkercad it's quite useful. Very convenient to just have something like that on the web. Also, yeah, shout out to this Google Drive folder, which is now been sent in the Discord DIY lightsabers. I'll pin it. Hang on. Where's pin? Pin message. There we go. It's pinned in the DIY lightsabers channel. This is great. We have I don't know if we have anything else that we will need from that setup. We might, if they have batteries actually, then that would be handy. But yeah, that'll definitely accelerate your progress. Let me see. What else we got? Yeah, I mean, we got the NeoPixel PCB that's always useful. Wow, even some Tri-Cree lenses and stuff. That's nice. Yeah, a lot of good stuff here. Even some chassis, it looks like, that you could take a look at for inspiration. Some batteries as well. I'm not as worried about the battery because what really matters is the case, and I don't see the exact one that we have here. I don't think. But we've already got a pretty good model of it, so I'm not that worried about it. Okay, our Profi board. Okay, it may not have been in millimeters because it is now quite small. So let me try again, and this time we will say inches. Bang. Inches. It's also possible it's in centimeters, in which case we'll go millimeters and then 10x it, but we'll see what happens. Okay, no, it is inches. That looks perfect. Excellent. Excellent. Okay, now we just got to grab these bad boys, teleport him over to there, down to the end, down to, I mean, we're gonna figure out the height in a second here, but there we go. Look at that. That is beautiful. Way better than our last little attempt. See, we were close on the SD card, but not quite right. And yeah, these guys absolutely knocked it out of the park. This is great. Okay, so looking at this, yeah, it's amazing. Shout out to whoever made this model as well. I don't know if it was the same people who made the board, but this is, yeah, excellent. Okay, now what I'm thinking now is we need to figure out how we can fit a plug in here, because we have to plug a thing in there, and these USB micro B plugs or whatever they are tend to be a decent size. Let me see if I can pick one up. It's quite dark because I wanted the lighting to look pretty for you guys so you could see my glowing sign. But this, alright, yeah, so you can see if we're working with a plug like this, then we need a good amount of space on the edge so that we can get this cord bent in there. We definitely need to be able to reprogram it so that the SD card is closer to the center of the core. I might want to rotate it. Rotate it how? And the port is facing the inside of the hilt. I don't know. I'm not sure how we would be able to, how we're going to be able to access the SD card. If we flip it upside down, then, I mean, I guess we could have a decent sized hole for the SD card to come out the top. Yeah, there's definitely lots of boards that you can do it with. The Profi is... The benefit of doing it with the Profi is that it's... first of all, it's an absolutely legendary design. And second of all, there's a ton of people doing it, so it's just... there's a lot of features and stuff that if you're doing it with another board, I think that was my mistake before I did try to do it with an Arduino RP2040 Connect board, which is a great board, and it could definitely have the same functionality, but you would have to do all of the programming yourself, which just takes a lot of time. It depends on, okay, convention is, okay, yeah, that's true, convention, yeah, so if we rotate it, if we flip it upside down, then, let me see, I guess that's fine, just as long as we can make sure that we have enough width, which we have to do anyway. We just need to make sure that we have enough width that this thing can go joot, joot, or something to that effect. Which at the moment I don't think we do, so we may actually want to push it back a bit. Let me check. We just need to figure out the optimal position, or at least something close to the optimal position, to make it as easy as possible to get this SD card in and out. Because that's, yeah, it's hopefully, ideally you wouldn't need tweezers, but if we can't get any better, then we can always resort to having to use tweezers. Okay, so considering, is it going to be a removable chassis? I don't know. The main reason that I'm leaning towards not is that the way they designed this hilt, let me pull up the camera so I can see what you guys are seeing. The way they designed this hilt is that so we have this thing on this side, which is what the buttons are hidden under, and then on the opposite side, there's kind of just a hole where you have those two screws, and there's a plate that you can put over it that matches this, that you can glue on, but there's not really any way to put it on other than gluing it on, which is a little bit of an unfortunate design choice, but it makes it unlikely that the chassis would be removable, because once you glue that thing on, you're not going to be able to unscrew those set screws to pull out the chassis. So you still could in an emergency, I'm sure, if you really had to get at something inside of this bad boy, you could pry that thing off and then re-glue it, but I think a static chassis will work best here. Okay, so say it's a static chassis, where would you suggest we move the board over to? The RP2040 is the bane of your existence. Yeah, I definitely agree. I think, dude, I don't know why I chose the RP2040 Connect for that lightsaber. It makes a lot more sense to just get a regular Nano and an MPU 6050, and there is already a library out there that does that handles the MPU 6050 and the regular Nano for making a lightsaber. It's called FX Saber OS. It's not as good as what the Profi guys have got, which is why we're going for a Profi Saber this time. But if you do want to, I guess, minimize the cost, because I think the Profi board is like $40 for the V3, maybe even more sometimes. If you want to minimize the cost, then you can go for this. It's just not quite as expensive as the Profi is at this point. Probably on the back of the battery holder. I'm a little bit worried about putting it on the back of the battery holder. I mean, this just looks, to me, this looks very tight. Let me show this. Pico with RP2040 is like under $7. Yeah, I think it's like $4 or $5, $6, which is $6 is how much the regular Nano is. So you could also get that. Oh, and if it has Wi-Fi and Bluetooth, then that's a win above the regular Nano, for sure. Let me hide that. I mean, the only L that the RP2040 would take is if it's not Arduino core, then sometimes they're a little bit harder to use. But at the point at which you're making a lightsaber, why do I keep hiding that? Okay, taking a look at this. Might also be better if you took the battery out and just used battery contacts. I was thinking about doing that. The main thing I'm worried about is the precision required to... Let me pop this out. The precision required to get these battery contacts... Because because you can just slide the battery contacts out the top. Or I think you could if you tried hard enough. Having a little bit of trouble at the moment. But yeah, okay, there we go. It's moving a little bit. So I could slide these out and then put them in the actual chassis itself instead. My main concern is the precision required, because this, for it to be tight, this is a very small slot. And the 3D printer we're working with, I mean, it's pretty precise. Not sure if it can handle that level of... that would definitely save space if we could, if we could annihilate that. Are there any other ways to get the SD out? I mean, we could also go out the top, potentially, if we had a divot here, but there would be a lot of space getting cut out, a space that can be used for structure, hopefully. We could move the board up a bit more. Let me see. Yeah, you can also just duct tape a 9-volt to the side of your saber hilt. In this case, the reason that you want to use like an 18650 is that it can provide current so fast. It can provide so much current at a time that it works way better than a 9-volt, which can't provide that much current. And also capacity. I mean, the 18650s have like... I think the one I have is like maybe 3,000 milliamp hours, whereas 9-volt is like, these have 5,000 milliamp hours, allegedly. And the 9-volt is like, I don't know, 500 or something, so a lot less. Alternatively, screw the SD removal and just use mass storage. Yeah, I mean... SD card is very convenient. Let me see. I actually haven't looked into that, so I don't know how difficult that is. Using mass storage Profi board. Let's take a look at this suggestion here. Well, that didn't help very much. Yeah, the crystal chamber complicates things a lot, definitely. But we are definitely not giving it up because it's too awesome. I think that, yeah, having a removable chassis would definitely make it easier, because then the Profi board could be up there for all we care, and it would just be easy to access. But like I said, the particular hilt situation, I think, makes it unfavorable to do that. Let me think about this. I think from a wanting it to be structural perspective, I think where we should go with is just keeping the Profi board somewhere around here. And if the SD ends up being super hard to remove, maybe you have to use tweezers, maybe you have to do whatever, mass storage. But I think we just give it our best and put it in roughly this area. We could put it alongside the battery, but I'm worried about structure, because these prints tend to already be a little bit easy to break. And it will be inside the hilt, right? And if it's a similar size to the inside of the hilt, hopefully, it doesn't get battered too much. But still, I mean, you don't want to, like, it's a snap off when you're trying to flex on your friends by unscrewing the hilt and then showing off your fancy chassis. Do I have 22 and 30 AWG wires? Ugh, I don't know. What do I have? Most of the wire that I have is stranded. So I'm not sure if you're suggesting I use it for structural purposes. But I think this is 22. Where does it say? I mean, I'm sure it says on the wire itself. It's just going to be a little bit hard to read. Yes. We got some 20... That looks like a 2. I think it's 22 AWG. Whatever the recommendation was for the amount of current that we needed, but it's stranded. If you use all 22, you're going to have 0 space. Oh, interesting point. Wiring space is probably going to be an issue. Yeah, you might be right about that. I mean, I have other gauges, so we can probably pick whatever gauge we need to. This doesn't, is it, maybe this is 24. I don't know. It looks a little thin for 22. It's quite dark, so I'm having a little bit of trouble checking, but it's 20 something. I can say that much. 200 degrees Celsius. I think it's 22. I think it's 22. Switches speaker. Yeah, that surprised me about the speaker, though. I don't know. Seems like the speaker might, I don't know, need more power, because I feel like it's got to pound out some sound. I don't know. 2 watts, 4 ohms. Maybe not. I don't know. And then making the board too close to the side and shorting. Yeah, I guess we do have to watch out for that. Yeah, that is a good point, routing wires. I feel like with this arrangement, though, I think that we have plenty of space to route wires, right? Because, I mean, look at how much space we have outside of the board and the buttons. Like, we have some wires going there, but, I mean, we can have wires in here, we can have wires below the board. I feel like we have a lot of space. I 3D printed a plastic case over a metal pipe for strength. Maybe you could do something similar, even just stick some small metal rods in somewhere. Yeah, that's a fair suggestion, putting some metal rods or some non-stranded, some solid core bare wire in it or something like that. Or, yeah, threaded metal rods, yeah, for sure. I wonder where one would acquire such a thing. Threaded metal rod. How thick are we talking here? Probably small. 1/8 inch? 1/4 inch? How much can we fit here? I don't know. I feel like if we're worrying about fitting wires, we might have some trouble fitting threaded metal rods. Also, time may be an issue. Unless it's on Amazon. Okay, hang on. Just in the side, like the TCSS stuff. Yeah, let me pull that up. Images. Last. I don't see any images of it. I'm sure TCSS will have some on their site. I don't love the TCSS style chassis, to be honest, if it's the one I'm thinking of. But what are we looking for? Chassis. Saber chassis. There we go. Nope. I don't think these are what we're talking about here. Let's take a look, though, just for inspiration. Oh, yeah, these are super simple. You just put the metal end caps in for the battery, and then I guess you put the Profi board there. I think we're looking at something a little bit more involved in this. Also, $30. Well, that's kind of crazy. I mean, I don't know what it's made out of. But let's see. So I think, getting back on topic, I think, let me see. I think I'll try going with the full 3D printed first, and then, we'll see what happens. If it snaps in half, then we'll have to change of plans and figure out some metal rods or something like that. But if it doesn't snap in half, then that'll be a win. I don't know what more we can do than that, because obviously it would be optimal if we didn't have to go with threaded metal rods, because then it'll be much easier to replicate. And also the precision, well, I guess, I don't know. I mean, I guess the 3D print doesn't necessarily have to thread the metal rods in through it, but that would be the strongest and the coolest. Anyway, long and the short of it is, I think we try it first with no threaded metal rods. We try the pure 3D printing approach, and if we can't get it to work, then we'll try something else. But also, if we can get the 3D printing approach to work, not only is it easier, but then it's also faster to go ahead and complete the project. So yeah, with that in mind, I think this is what we're going for. Also, YouTube is telling me that the stream's bitrate is super low. Does it look terrible? Someone tell me if it looks terrible, because I have no idea what it looks like. Okay, but I think that what we do, yeah, is, okay, it's good. Okay, that's good. Okay, so I think we need to go ahead and, okay, the main question at this point is how high the Profi board should be since we are going to try to put it in this area, because we do need some space. Let's see, so we're gonna have I'm not sure the pinout of the Profi board off the top of my head. We do have, there are going to be connections going to each of the buttons. I'm guessing the Profi has, does Profi have internal pull-up resistors? I think it does, right? It does not. Okay. Good to know. So, blast. I guess, so we have to do a 3-wire button setup. That is not the Profi board. Okay, so if the Profi does not have internal pull-up resistors, then so basically, if you don't know what an internal pull-up resistor is it means that when you have one of these pins on your board, if you're connecting to a button, then you might connect the button to ground on one side and then to the pin on the other. So when you press it, the pin gets connected to ground. But if the button isn't pressed, then it's not connected to anything at all. The pin isn't connected to anything at all, so there could be electrical noise, which could make the pin be literally anything. So what you tend to want to do is connect the pin to, for example, the 3-volt power line, and then when it's always going to have 3 volts until you press the button, and then the 3 volts starts going to ground, so the pin ends up being at 0 volts. The helpful thing is if you use OBS, set up a second monitor, and use studio mode, which allows you to move around widgets. Yeah, no, I have OBS over here, so I can move myself around if I want to. I'm going for a ride. It looks. My concern was if it looks fine in OBS and YouTube is getting unhappy, then maybe YouTube isn't getting a shiny, crispy video feed. But if it looks fine to you guys, I don't care how it looks. Aside from that. You're going to do a separate data wire for the crystal LEDs, right? Yes, for sure, yes. The Profi has the accent LED or whatever, so that's just what I'll do there. I figure it will be the same as the blade most of the time, but you never know. I mean, maybe you want to have it do some kind of flickering pattern different than the blade's flickering pattern or something. So yeah, we should probably have it be separate. That's what I figure. Let me see. Oh, you also mentioned studio mode. So I might have to look into that because I think I'm in the other mode right now. But oh well. I'll take a look at that. Okay, so we have the buttons in place. We have the Profi board. We have no idea what height we should be putting it at here, so this height looks fine to me. I don't know. The main thing is we want to make sure that we have enough space for wires to go to the buttons, but we also want to make sure that we're not causing a short with touching the inside of the hilt, because obviously the inside of the hilt is metal, so if we had a couple of pins touching, that would be bad. So I think if we have everything roughly in place, then I believe it's time to actually start kind of building out the chassis itself. Because obviously currently all we've done is place pieces around. The battery is much too high at the moment. Let me move it down. There we go. It should be roughly centered now. Yeah, 2 millimeters on the top, 2 millimeters on the bottom. Perfect, perfect. Okay, anyway, so yeah, what we need to do is we need to actually start building some structure that's going to hold all of these things together. And hopefully, we'll somehow be able to make it hold all of the things together while also looking nice. Okay. I'm wondering if we should go ahead and just have the speaker be glued to the bottom, or connected, probably glued, to the bottom of the battery. I feel like sometimes some chassis do that. Okay, let's not make it move that way. 3.5. Yeah, because if we just directly glue the speaker on there, then all we have to worry about with the rest of this is just connecting up the upper part, so then we wouldn't have to worry about the speaker too much. Of course, we do have to get wires there, which is something that's good to keep in mind. Let me see, what do the speakers connectors look like? Yeah, the speaker just has a little connection point on each side, so we should just be able to run one wire there. I think we have enough width for that. Let me see. Yeah, that looks like plenty of width to me to run a one wire down there for the one side of the speaker, one wire down the other side for the other side of the speaker. We do have to connect to the other side of the battery, so that might be the problem with that. The speaker is... let me just double check on this, because I forget if it's 22 or 24. It's a 24 millimeter speaker, and it ends up being roughly 11 or 12 millimeters thick as well, which is I think what I have here. Let me double check that this is the correct size. 8. Hang on. That's not right. Okay, that's a good thing we checked that, because it did end up being, I don't know why I had 8 on there, because yeah, this is definitely at least 11 millimeters thick, maybe even 12. I think we have a little bit of extra leeway at the bottom of the hilt, because we do have, the pommel does unscrew, so we have, this is the bottom piece, and then this is the pommel, which does unscrew, so yeah, we have a little bit of leeway that down at the very bottom of the hilt, but we do want to make sure that it's pretty accurate. Let me double check the measurement on this again, see if we can get some, yeah, okay. Yeah, it's a little bit tricky to measure this bad boy. Yeah, it's roughly, might as well do it in millimeters. How much do we have it at currently? We currently have it at 132 millimeters. Yeah, that seems about right. I mean, I feel like it's a little bit more. Yeah, honestly, it's more like 150 millimeters. I'm gonna go with 140 just to be safe, but I definitely think it's closer to 150. Okay, so with that in mind, let's go ahead and align the speaker with the bottom, of course, of the hilt, the end of it. Then I'm thinking that we can go ahead and have the battery casing butt up against the back of the speaker, because if we take a look at this is what it would probably look like if I can get my fingers out of the way, then we can see there's a little bit of a gap between the speaker and that one side, so we should be able to put a wire in there prior to attaching the speaker on the end, and these two can butt up against each other, and that should be pretty good. I think that'll be okay. So if that's the case, let's just go ahead and move this bad boy down without moving it side to side, and there we go. It doesn't have to be exactly touching, because obviously we can just make it touching in the actual physical world. Okay, so I think speaker is in good place, battery holder is in good place. Obviously we need to add some structure around the battery holder, and we need to make sure that it's the right width, you know, so it doesn't flop around or anything like that and snap off at this midpoint, which is probably where it's going to be most stressed. So let's figure out the crystal chamber. I think that's going to be the hardest part. Do you think a lightsaber with speakers running down the blade would be a good idea? I mean, it would definitely be. I think if rather than putting speakers down the blade, if I was going to put something down the blade in addition to LEDs, I think I would put some matter of force sensor or something like that, because then you could get very accurate detection of where the blade was getting hit. I mean, just imagine if you had a force sensor on every single LED down the blade, then, you know, whichever LEDs were hit, you could light up just that specific area, and it would look, I mean, it would look insane. Obviously, these lightsabers already look sick just lighting up, you know, guessing where the impact is based on a single gyroscope. But if you had, yeah, I mean, if you had force sensors or something all the way down the blade, I think that would potentially add something. I don't think speakers all the way down the blade would add very much, aside from volume. I think that's the main concern is volume, and possibly it coming out of only the bottom. You know, it doesn't come out the top as much. But I don't think speakers all the way down would add that much to it, to be honest. The board placement is a bit worrying for the USB port and the SD access because the crystal is right there. Yeah, that's what I'm not sure about. I feel like the battery holder is taking up... Should we go rogue and annihilate the battery holder? Maybe we should. You want the speaker to only shoot sound out the bottom. Yeah, for this build, that's definitely what we're doing. I think in a theoretical world, though, I mean, theoretically, it would be good to have sound coming out of the top somehow as well. Because, I mean, I don't know where in a lightsaber the sound actually would be coming from, but presumably where the plasma or whatever is coming out, that would cause sound as well. I don't know. But yeah, in this case, we need the speaker to be at the bottom because that's where the venting is, so that's where we want the sound to be blasting out of. Yeah, you couldn't really put holes in the blade for the sound to come out because then it would mess up the LED's diffusion. And you would just have little specks of light all around when you swing your lightsaber around, which probably wouldn't be ideal. Resonance is best out of the bottom. Maybe you'd want the sound to come out of the blade in canon, but it need to be some magic. Yeah, no, for sure. Yeah, I think in practice, with technology as we have it now, yeah, I think you're definitely right about the speaker being at the bottom. Okay. So yeah, how on earth are we going to design this crystal chamber and not ruin our being able to access our board? I don't know. Maybe we have to figure out how to make it a removable chassis. Yeah, because I mean the only issue with it being a removable chassis is that we have this little spot right here, which there's a cover for it that looks just like this side does, but you have to glue it on. So that the fact that you have to glue it on is the only issue. If you're willing to not worry about that slight cosmetic defect of having this dark spot here or whatever that doesn't have a shiny thing covering it, then we could just make it a removable chassis. You could just use those two set screws to hold it in and remove them, and then you would be chilling. So that could be what we do, because if we do something like that, then all we have to do with the Profi board is spin it around, and then we have plenty of space at that end. I know some Fallen Order sabers have a crystal at the pommel, and then you would get some lighting there too, which would be cool. Definitely would sacrifice sound quality. Yeah, no, I have seen that, because this is our pommel that we're working with, so you can see there's a bunch of holes in it. So if you put a crystal down there, then, especially with as small as the crystal is, it could probably, where is it? It could just stick down in there, and then you could actually see the crystal glowing through. How do I make this look good? You could just put the crystal in there, and you could see the light glowing through those and everything, and that would look kind of insane. 24 millimeters in this cell isn't going to sound amazing anyway. Interesting. So, yeah, I mean, well, I'd actually be interested to learn what factors contribute to that, because I don't think we can fit a 28 millimeter speaker in here, right? We don't have, wasn't it 20? It's 27 millimeters, right? It's like 20. Yeah, we couldn't quite fit a 28 millimeter speaker in here. I don't think there's 26s, so I think we have to go 24. Yeah, I mean, definitely choosing an aesthetically pleasing hilt may cause some issues, because the good looking ones always have skinny sections and generally are skinny in general, which means that it's a lot harder to fit the electronics, to be honest. How is a 20? I would think that the larger the thrumming part of the speaker, the better it would be. So I would think that a 24 would be better than a 22 pretty much always. Oh yeah, the graphic sabers are fat, dude. A 34 millimeter speaker would have to be loud. Yeah, I mean, to be honest though, I mean, I understand, like, if you're an older person and you want to have the Graph Saber for the nostalgia, but to be honest, I never really liked the Graph Sabers too much. I like the Obi-Wan style saber. If you're gonna go for something original trilogy, or even prequel trilogy for that matter. Yeah, I think about it, I've owned a lot of sabers and there's never been a good 24. Okay, I mean, that's good to know, I guess. Where do you get a 22 millimeter Vicos or whatever that is? Is that something you can get at TCSS? There's only one. TC. Okay, so this is it then. I'm guessing, because this is their only 22 millimeter speaker currently in stock. Okay, noted. I don't think I'm logged in, so it probably won't save, but I'll remember. Possibly, I might remember. I'll definitely remember that you said that there's never been a 24 millimeter speaker. So hopefully in future, I'll either go 22 or 28 or something. And we'll see. And maybe at some point I'll have to just grab a bunch of speakers and do a sound test, because that could be good. Yeah. Okay. Well, I'll yeah, that'll be the speaker for whatever my next build is. I think I'll probably go ahead and build this one, because I've been attempting to build this one for a very long time. So I need to actually get it built, and I probably don't want to wait for TCSS. It takes a while, I think, to get not to ship. I mean, I think they ship pretty quickly, but for the whole process. So I think we'll have to stick with the 24 for this one, but in future 22. I'll take notes. You can fully enclose them in the space of a 24, and it will pretty much always sound better. Okay, yeah. No, I am in the US, so it's not... Also, okay, to be fair, it probably only feels like a long time because of Amazon. Because when Amazon ships you something in 2 days, in 1 day, sometimes in like 8 hours, it spoils you. And then you can't... And then it feels like a long time when you order something from anywhere else. The real long time shipping is when you buy a Profi board off of AliExpress, because that's the only place where they are very, very cheap. But yeah. What about putting weights in the pommel to have a better blade balance? Yeah, definitely, especially with the NeoPixel blades, because they're quite heavy, to be honest. Like with a hollow blade saber, they're very fast, they're very whippy. You can spin them very quickly, very easily. But yeah, with the NeoPixels, they're quite heavy. So yeah, counterbalancing it could be good. Again, I don't think we'll have space on this saber. I don't know. Maybe we could squeeze something in the pommel if we don't end up putting the crystal down there. But Yeah, it's definitely a good idea balancing it, because they're not balanced at all, especially considering they're supposed to be plasma for the blade, which would mean it doesn't really weigh anything. But yeah, I got a V3.9 for 31 Canadian. What is that in freedom dollars? 31 CAD to USD. What? 20 bucks? That's crazy. That's crazy. Yeah, because I got this one off of AliExpress. I forget what it was. I think it was like closer to 40 though, to be honest. So yeah, that's a steal. 20 bucks. Man, that's crazy. Yeah, anniversary sale. Yeah, that makes sense. A big sale like that. Closes March 20. Okay, so I might have to get on that. Maybe I end up ordering some cheap Profi boards and the 22mm speaker and building another one after this one. We'll see. We'll see. Okay, so we need to lock in and finish this saber, hopefully at some point. So what are our options? We could move this bad boy down there and put the Profi board here. Maybe not quite there. Where would we put it? Here? Can we put it in an angle? Am I gonna get in trouble for doing that? So we could put the Profi board somewhere around here and put the crystal at the end of the hilt. We could make the hilt removable and put the Profi board down here. Or we could just move it down a bit like this, and then hopefully it still works out somehow. Angling it is a thing, pretty convenient, but you haven't tried it yet. I don't know. Okay, let me see. Yeah, I think I'm gonna rule out putting the crystal at the end, because I think it would look sick to have the crystal glowing through this. But I think trying to figure out how to put the crystal past the speaker and still have enough airflow for sound, and like if we're already having issues with the 24mm speaker sound, I don't think we want to make that a worse situation. So I think either we put the Profi board here, or we put the Profi board... No, we've ruled out putting the Profi board here. Either we put it here, or we put it here and make the hilt, and make the chassis removable, which adds a slight cosmetic issue to the outside. So I guess the question is whether we want to have trouble adjusting our SD card and data port, or whether we want to have a slight cosmetic thing on the outside of the hilt, having it not covered up with our little silver thingy. That is the conundrum that lies before us. Well, once it's done, you probably aren't going to be taking it apart. That was my thought. Yeah, that was my thought. Yeah, because you're really not going to be taking it apart that much. I'm really not going to be taking it apart that much. To be honest, if at all. Like, I feel like I'm just going to upload a fat stack of sound fonts to this SD card and then honestly not pull the SD card out, or probably edit the configuration that much once I get it working. And while I'm getting it working, it won't be in the hilt, so this will presumably be more accessible. And yeah, do what looks better. Okay, yeah, I think I'm sold. I'm sold. And the auction goes to Saffron. I think we lock it in. We end up putting this thing roughly around here because we're not going to be editing it that much. Okay. Yep. Let's do it. Okay, so this... that is in place. That is in place. The main thing that looms over us is the crystal chamber, but we also need to figure out how to just build enough structure around here that the buttons stay in place and the Profi board stays in place. Do you intend for the crystal to be viewable from all angles in the chamber, so the chamber taking up all the space horizontally? I think my concern with putting the it's most of my concerns with stacking items next to each other are about structure, because blast it. Viewable from one side only for sturdiness and a wire path where the chamber isn't. Yeah, that's what I think that we have to add. I think it has to be probably viewable from mostly one side, because I think, yeah, honestly, if we put it in the center and then had it viewable from all angles, like 4 supports or something like that, is probably not going to be strong enough. I think we have to put it, I think we have to have like a good thick section on one side of it, probably on the bottom side, because I feel like you're going to be unscrewing and looking at the top side. So probably on the bottom side, I think we want to have a good thick 3D printed section with high infill there that will hold the saber together. And then, yeah, it'll probably be viewable from, you know, like 180 degrees or something like that is probably the correct choice. And then, yeah, also a wire path that's a good point as well. And we can have the wires go there. Yeah, I'm still not sure if there's anything we can do to make the battery situation not look ugly, but because the batteries themselves are already, well, they've got words on them, and the words aren't in Arabic, they're in English. So yeah, I think we're gonna be kind of cooked there. I don't know, maybe we could tape off the ends and spray paint the batteries. That could be a fire hazard, I'm not sure. So can you set different parts of the saber with different info percent for 3D printing? It depends on the slicer, which depends on what we're printing it on. In my case, what I'm probably going to be printing it on is an older Dremel 3D printer that I have, which does not allow you to do different percentage infills in different areas. So we'll probably just have to make everything high infill, which honestly we might have to anyway, because it's a chassis and it's probably going to be pretty fragile, so we might just make everything super high infill anyway. The other thing we have to think about is supports and print direction. So we will, why don't you use Fusion 360? Well, for one, because I have very little experience, so it would take even longer than it will in Tinkercad. But for another more important reason, because obviously I should probably learn Fusion 360 more, this is free, it's online, any of you can go to tinkercad.com right now and do exactly what I'm doing, so I think that's a win. And also, once it's done, then I can just drop you guys the link to this, and then you'll be able to just access it and take a look or whatever, copy it and make your own modifications or whatever you want to do. So yeah, just I think it's generally best, if possible, to just use tools that everyone can use, because I think that's a win, so that people can follow along and learn more. That's why I also use, I don't know, like KiCad for PCB editing, because free and open source, it's just a win for everyone. So, let me see. We need a good thick section here. We need to be mostly viewable from the top here. About 180 degrees of visibility. How many wires are going down from the Profi board this way? So we're going to have one for each side of the speaker. We're going to have one for each side of the battery. And let me see. So the LED will be powered by just direct lines from the battery. So just one data wire to the LED. But then also, yeah, so there's 5 wires. We have 2 power lines, 2 speaker lines. Actually, no, one of the speaker lines. How is the Profi speaker wired? Hang on, I gotta pull up a wiring diagram. Profi wiring diagram. Let me take a look. Yeah, there's dedicated pins for the speaker. Okay, yeah, so we have to have 2 wires going to the speaker. The pixel LED negative needs to go to the Profi. Oh, okay. Interesting. So, oh, I'm looking at the diagram on my second monitor. That's probably not very helpful for you guys. Isn't there a Prusa profile for that printer? Unfortunately not. There are Prusa profiles for the 2 of the Dremel 3D printers, but the one that I have, I tried my best, but I could not get a Prusa profile working for it. So yeah, that would be very nice, because the Prusa slicer has a lot more features than the crusty ancient slicer. Hang on, I'll show you guys this right quick. It's a bit of a tangent, but this is what I'm working with as a slicing environment. If it loads, here we go. You also might want to wire from the blade positive directly to the battery positive. So if there's wires going from, if we're worried about wire widths, then we can, yeah, that's fine. If we're worried about wire widths, then we can split the wires that are coming from the battery positive here, or, you know, here, well, something, so we can split them higher up, because then there won't be as much of a width constraint, I believe. So yes, the battery positive will go directly to the blade positive, because that's how we're going to get the most juice, but we can just split it here, and then there will only be 1 wire going through. I think it's just better. And then what about metal 3D printing spools? Wouldn't that solve the snapping in half issue and add some weight for counterbalance? So the metal infused filament is, it's not a lot more structural, because at least based on what I've found, because it's just specks of metal. It's not like the metal is really adding a whole lot of structure. It's not like adding a metal bar. It's just that the powdered plastic got mixed with powdered metal pieces, and at the heat at which we are melting the plastic, I don't think it's going to be melting those metal pieces very much, so it's not going to be, I don't think it's significantly more structural. It would add counterweight though. It would add counterweight, and it looks very cool. So we might do that. Let's see, because otherwise you'll have 2 wires going to the battery positive on the board, and you'll need to do some other splicing. Instead, you can just wire to the battery plus contact on the holder. Yeah, I mean, either way, it might be easier to just connect it to the battery plus contact on the battery holder, because it's a pretty fat contact. It's got plenty of room on there. Or splicing. Yeah, could go either way. But so maybe we have maybe we have 6 wires. We'll just plan for 6, and that should be fine. Let me see. So we need enough space for 6. Yeah, and we'll add extra space anyway, if possible, just to make sure. Okay, so we need to plan for 6 22 AWG wires to go through here, while also ensuring that there's enough structure around the crystal, there's enough structure in the chassis period that it doesn't fall apart, and making sure that we have roughly 180 degrees of viewing angles for the crystal from this side, which don't have to be unobstructed. I mean, crap, this is a lot of tabs. I don't know where all these came from. It doesn't have to be unobstructed. Like you can see here, this is probably 180 degrees viewing angle, but we still have 2 posts, so you can see it here, and then you can, I think, see it from these 2 diagonals. Pretty similar thing here. Actually, they have pretty limited viewing angles here. But anyway, yeah, we can, honestly, I have no idea how to 3D model and make it look good, so we'll see what happens. I'm just gonna obsessively close these tabs if that's fine with everyone. I'll leave that one open so I remember it. Yeah, no internal pull-up resistors, so extra wires. That's kind of unfortunate. Okay, it's going to be so painful with all the 22 AWG, trust me. Please use 28 AWG. I mean, how fat are these really? Hang on. 22 AWG width. Well, can I get some numbers? Thank you. Somewhere down here. Okay, enter gauge number 22. Calculate. Diameter in millimeters. 0.6438. So we have 6 of those. What is the optimal arrangement for 6? I guess just 2, 3, 2. Okay, so what we need to do is we need to take a look at what 6 of these wires is going to look like. Bang, bang. They don't look that fat, but I swear when you start needing to push down the board and cram that through, then we run out. Okay. Let's just take a look. Let's just take a look. Blast it, my snapping is too small. Or too large. Okay, 0.5 millimeter snapping should be fine, right? How is it ending up offset? Alright, let me try this again. Duplicate, move, zero this out, move this one, I guess this much, maybe a little bit more, because we have to be realistic here. Let's just move it 1 millimeter. Okay, then let's take 2 of these guys, duplicate them, then duplicate those and move them down here. Is that centered? I think that's centered. Then duplicate those and move them here. And I don't think those are lined up. I think I screwed up. Let's try this again. We do not want to move them to the side. We only want to move them here. Okay, these are very spread apart. I feel like we can definitely get them closer together than this, even in the real world. Also, this is 7. So I don't know what I'm doing here. All right, let's figure out how we can bring these bad boys closer together. Can I just get a top-down? Do they have a toggle for? Yeah, there we go. That's what I'm looking for. Much nicer. A little bit of an orthographic view. Okay, let me just turn off snapping and just line all of these up in a nice close arrangement. Okay, that is our arrangement. Now we can go back to perspective. Okay, so theoretically, we need to create a channel that is large enough for all of these. If we go with 22 AWG, which we can theoretically swap some of them out for non-22 AWG if we are having trouble with space. If we're having trouble fitting, we'll just do a test fit where we shove the 22 AWGs through, and then if we can't get the 22 AWGs through, then we'll switch some of them out for the 28s. I think that's fair. Alright, so this little box, let me make it a tiny bit larger. 2.5, just round it off, 2.5. I don't even know what we're talking about at this point. I think millimeters. There we go. Alright, so this little square right here is the size of our wires. So we are going to, I think, vanish that. And then we can just move this bad boy in. Not those. Now let's line this up and move it down. See, why would we want to move literally every single item? I mean, I guess it doesn't matter. We can move them all. That's fine. I don't know why I wouldn't just move the one to join the group, like follow some peer pressure here, but I guess not. I guess they're not promoting peer pressure. Okay. Let's lock this in. And here we go. That is our wires. Okay, they need to be a little bit lower. Hang on. Hang on. Our wires are like this up to here, and then they're probably going to go up and in the middle here, so we can still access our SD card situation here. So let's go ahead and move them down a little bit more, and then we can just duplicate this bad boy, and okay, why did I make it suddenly very tiny? How wide is, let's just retry. Just trying to make a little path for this, for these wires. There we go. Not quite. Beautiful. Dude. I keep pressing W because in like I don't know, Unreal Engine or whatever game engine, maybe Unity, those are that's the shortcut for switching to the arrow key, so I keep hitting that kind of a lot. But there is no arrows here. Okay, 0. Let's make this I don't know, 39. There we go. Our wires are gonna go like that. Okay, nice. Now we're also going to have, is there going to be a cover for the crystal, or will it be left open? I think it, the idea is that it gets left open, mostly open for 180 degrees. So everything on this top half here, all of those angles, you can see it from. There might have to be a couple of supporting posts across, but hopefully most of that is left open so that you can see it, and then the back half is probably going to have to be covered just so that we have enough structure and so that we have somewhere for the wires to go through. But yeah, ideally most of the crystal is open, or at least half of the crystal is open for everyone to see its glowing beauty. Okay, so we have a wire going here, a wire going there, then we have 2 wires going from this side through there, and then we also have 1 wire dropping down there. That's actually really convenient that we just have that boink just going right down there and up there. Yeah, I think I like this. I think it's looking pretty good. So yeah, with the we have to figure out how we're gonna hold the crystal in, because we need to be able to access most of the bottom of it. Well, not most of it. We need to be able to access 3 of those pads so that we can provide it with power and then also data. So that is going to be interesting. How are we going to hold this bad boy in place? So we might have to like put some kind of a ring around it. I'm not sure. To be able to hold it in place. Should add some more room for those wires, then you're going to have a really hard time fitting those through. Yeah, okay, yeah, that's fair. We'll add some more. I always make the tolerance too small, so I'm happy to listen to some additional wisdom there. 4.5, that seems like a lot. How about 4? And I guess actually we should probably make it, based on what we're seeing here, we should probably make it short and fat. 6. How big were our wires again? 0.648. So if we make this bad boy 2 millimeters tall, and then we just put them in all 6 next to each other, because there's going to be a lot of friction. Maybe you missed some insulation. Yeah, no, I got you. I always make these too small, like I said, so I definitely need to make sure that we make these plenty big. Okay, so imagine it's 7 millimeters wide. We have 6 things, and they're each less than 3/4 of a millimeter, so that's a lot of extra space. Then the height is 2 millimeters, and they're again less than 3/4 of a millimeter. I think that's a lot of space. I think it's a lot of space. that seemed like a lot of space to everyone else. And then this guy, okay, the wires are obviously not actually gonna make a straight line like that. There's no way you're gonna be able to force them in and then up and then through. What shape do we make this? This area, I think we have plenty of, I think honestly we just make this, I don't know. How are we gonna, because trying to make wires bend around a corner like this is gonna be very difficult. So I'm trying to think how we can get the wires through. Is the board going to be that deep into the chassis, by the way? It can be a bit closer to the edge of the hilt so that the wire channel there doesn't need to be angled. Is the board going to be that deep into the chassis? Oh, it can be a bit closer. I see what you're saying. Yeah, there's actually really no need for it to be that high up. You're right. As long as we're not causing a short and as long as there's enough space, we are chilling. But let's see. We need to have enough structure. I'm trying to think, how is this Profi board going to be held in? I'm guessing we're going to have a bar, like a bar of plastic on each side of this port here. And that's probably going to have to be how it's held in. S-curve for the wires. Yeah, I don't know how. Let me see. How would we create that? I like the idea. It would be very elegant, but I'm not sure if we can create that, especially given the constraints of 3D printing. That's what I'm trying to think through here. And so you have more room under for fitting the board in, because dude, the 22 AWG wires will be fine, and if they're not, then I'll be sad in the video, and you'll know why. Okay, so the board, yeah, I'm not sure how it's gonna be held in. It's gonna be interesting to see. Yeah, no, so the S-curve for the wires would be sick, but I'm not sure if the 3D printer can print an S-curve. I'm trying to think what angle the 3D printer is going to print this at, for support-wise and everything. What is most structural? Let me think. So most structural is probably honestly lying down like this, because if we printed it standing up like this, then the print lines would be, going like this, which means that it's easiest to snap like that, which is probably where it's under the most stress. So lying down like this is probably the best case. I mean, at some rotation, it could be any rotation, but lying down is probably the most structural. Of course, we have to consider the size of the 3D printer. Let me get everything in here. I don't know, in millimeters. Dremel 3D20 print area. Hopefully it's in millimeters. Let's take a look. 140. Okay, so print size may become an issue. Let me see. If we want to print it lying down, then we have to fit it within 140 millimeters. And maybe not an S-curve, but a curve in general. Yeah, definitely not a straight line like this. You're right, definitely right about that. How on earth do I create a curve in here? I guess maybe we use one of these tube shapes, and then we can cut out the size that we don't like. Have as much empty space as possible for those wires. Yeah, why don't we eliminate that for now, and then once we start building in the structure, we'll just try not to build anything there, and then hopefully there will somehow be room, and maybe we'll add some kind of curved guide for them if we need to if we can figure it out. Let me change that one's dimensions to be the same as this. I made this one 7 wide and I think 2 tall, right? Okay, show me the height. Yes, 2 tall. So this one is going to become 2 tall and 7 wide. Okay, so we'll figure out the connection point between those later, but now we need to actually hold this stuff together. And won't the detail of the print be a problem if you print it sideways? Yeah, that's... yeah, that is a concern. Because, yeah, you're right. It won't look as good if we print it like this, because then all the lines will not be as good. Yeah, so given height and looks, well, we still only have 230. How much was it again? How much is it at the moment? Oh, it's only 203. Yeah, so we might have to print it standing up if we can figure out how to do it with supports. Also, the entire area under the board will be empty space, right? Like a giant rectangle. Dude, I'm so worried about all the 22 AWG. Under the board. Well, we have to figure out how this board is being attached. Like, do people just, like, glue it on there? Like, I mean, surely we have to put something under it, right? So it stays in place? Let me see. The board. Duct tape. I mean, if it works, it works. It's gonna be in the part of the hilt that no one ever sees. So I wouldn't mind doing that, but if we want to set a educational example for those who come after us, then we might have to come up with something more elegant. You can hold it in using E6000 or Captain tape. Okay, I mean, I guess, yeah, maybe we just tape or glue it on there. That's fine. Much easier than having to figure out a support, and in that case we can move the board even lower. Oops. Is that too tight? Slightly worried about tolerance. Let me go back. Yeah, plenty of tolerance. Alright. Maybe model a small pocket. That's what I was thinking. My main concern is General seems to be suggesting that we need extra space for the wires. Well, not suggesting. He's very clear that we need more space for the wires. So, and he knows a lot more about building lightsabers than I do, I think. So I have to trust him on this. So, yeah. We may have to do it lower because of that. You should expand that red square onto the board. Okay, yeah, the red squares are just a suggestion, but I can expand it. 3. Dink. And then we'll make him 3 as well, because I don't want to be unfair to one of the red squares. I feel like it's got to be plenty of space, right? This is, I mean, 3 by 7, and each wire is only 0.6 something in diameter. So like 6 of those seems to be a lot less. Make it a giant rectangle the same width and length as the board. I mean, I don't know. I mean, I trust your judgment, but like, it's like, if we think about it first, it seems to me like, just thinking about the numbers, right? If they're all 0.6 in diameter. Wait a minute. No, it is in millimeters. Yeah, if they're 0.65 millimeters in diameter, I mean, we could just line them up next to each other and they still wouldn't come near 7 millimeters. And it's 3 millimeters tall. And deep enough to reach the switch. Okay, I think there's a confusion. The red square was these squares were supposed to be representing the holes for the wire. So let me make them holes, and then let me make a new square. And then, yes, we do need to make the actual solid part of the chassis, because they have insulation that possibly differs from the calculator. Oh, that's no insulation. No, you're saying that's no insulation. I got you. Last. You don't seem to have any help. Oh, let me just see if I can measure mine. I don't have calipers, so it's gonna be kind of rough, but Okay, yeah, the insulation's pretty fat. You're actually, yeah, you're definitely right on this. I'm gonna say 0.15. Or 1.5 millimeters. Okay, so 1.5 millimeters, then 1.5 times 6 is gonna be the 9 millimeters. So let's go ahead and make this Okay, I'll just click the button then. 9 millimeters wide, 3 millimeters tall. 9 millimeter. Dang it. 9 millimeters wide, 3 millimeters tall. Yeah. I did not realize that was like 0 insulation. I did think there would be variance in the insulation, but I didn't think of the fact that would be 0 insulation. And remember, the solder pads on the board are on the sides. Solder pads on the board are on the sides, hence why I mentioned the red rectangle being the same width. Yeah, oh, because it has to get there. Yes, it definitely has to get there. We have to figure out... Well, this is interesting. This one actually has the regular pads, which there is... I don't think any way that 22 AWG wire is fitting through all those holes. I don't know. Maybe it can. Untinned, maybe? I don't know. See if I can stroke it with my fingers and see if I can get it to work. Yeah, that seems definitely too fat, right? Oh? Yeah. 22 is definitely too fat to fit through those holes. This is kind of a weird design. I feel like, yeah, most of them are on the sides, like you're saying, but this one, they are proper holes. Or maybe I'm thinking of another board, who knows. Okay, so they do need to get down. Which ones do I need to check the pin out? Because we have to have, obviously, connection. What am I saying? I guess it doesn't have to be full width at this point. Like the, okay, so just to clarify, at this point, the red is now solid, and I've transitioned the holes for wires to be actual holes. Okay, so the red could be this. The hole could be this. Maybe make the red square a trapezoid to reach the board. Let me see, a trapezoid to reach the board. I do not know what you mean by that, to be perfectly honest. Okay, this extends up to here. Then the buttons are going to have little things sticking off here, so they can just be soldered on top there. Then the red square needs to extend. The hole needs to extend, but not that far. I'm gonna have to leave for a bit. Okay, yeah. I'll possibly be still going. I don't know. I'll get tired at some point and go to sleep. But I'm glad it's fun, because I was afraid that it was gonna be mad boring for you guys just watching me struggle at 3D modeling. Okay, let's see. We have the holes here. They look like, okay, I think that's good. Now, we still haven't figured out what we're doing for the space here, so let's just not worry about that yet. Let me see. Let's hide this for a second, because this can just go as far as we need it to go, to be honest. Let me see. Yeah, we have to have these sides here so that the wires can go down, but then after the Profi board, this can become full width, right? So right here, this can become the full width. And I guess maybe we'll just do a cutout using this circle. We'll just do a thing to cut this out, possibly. Okay. Let me make it the proper length, though. Right there. Sure. And this one does not need to be nearly that long. Okay, so currently we have the buttons can be just glued on top there, right? That seems reasonable. The Profi board gets glued onto the bottom. This, I guess it doesn't matter super much, but we can potentially extend this one down a tiny bit more. Yeah, there we go. Okay, so it gets glued onto there, and that part doesn't have to look good because it's going to be hidden away. The only part that really needs to look good is the crystal chamber, because I don't think we can possibly make the battery look good. Honestly, at this point, we might not be able to make the crystal chamber look good, but, you know, we'll see what happens. Is everything still center aligned? Because I think some things have become uncenter aligned, so as long as it's okay for everything to be center aligned, I think I'm going to just center align everything. Bang. Yeah, we've still not yet created anything non-center aligned. Okay, cool. Alright, we have at least a bit of the chassis in place. Now, we need to figure out, I guess, yeah, the main thing is just that we don't know what on earth we're doing for the crystal chamber, and then we just need to build some structure around the battery section, so that it stays together with the rest of the hilt. So, eyeball it. Yeah, that's what we... So, yeah. It's a good suggestion, I would say, for a good 3D modeler. We'll see what happens. We'll see what happens. Eyeballing it may not be my specialty. 3D modeling in general is not my specialty, but we've gotten pretty far tonight with your guys' help, so hopefully we can come up with something good. Let me see. Okay. Let's just pick one of these that we think looks pretty nice, and then try to kind of rip it off a bit. Whoa. That's so sick. Oh my goodness. Alright, at some point we're gonna have to do something like that. These, I mean, obviously this isn't an option for us because we do not have whatever metal this is made out of. This is probably fairly weak even though it's made out of metal. And made out of plastic it would just snap, but that is pretty epic. No, that one doesn't really show the crystal. This one is a pretty good option, I feel like. Obviously we don't have two crystals like is happening here, but doing basically this, which I think this is the other side, if I'm correct. So what they have, actually, I don't think we're gonna be able to 3D print that. That's too many little things with no support in between. We might, yeah, that might be difficult for the 3D printer to do. Yeah, we might just have to go with a boring thing on that side, and then on this side we can do like some posts or something like this, because we do need some level of support, presumably. Alright, let's add... what do I want to do? We probably want a curved bottom thing here, so we need to use this to cut out. We need to just create a shape here and then use this thing to cut it out. Let's see. Give me a cube, please. So we just drop this bad boy in. We make him go down pretty far. Because we're going to cut out the circular part, and then we make him go to here, maybe. There need to be wires here at some point, but we can, if he's half, let's see, we want him to be halfway up, right? Because we want 180 degrees of viewing angles. I think that's halfway up. Okay. So we take this, and then we just need to cut it out. So to cut it out, I think what we have to do is we have to create just a massive box that is just utterly huge in every direction. And then this box nope. This box, extend, is going to, we're just going to cut this out of it. We're going to cut the chassis width out of it, so it's effectively, So now we won't be able to see it, but we do have that. Actually, hang on. I'm realizing that we are still going to want these, so we have to duplicate them before we do that whole cutting out. Duplicate them, then show this. Now we can't see it, but there is a cylindrical hole in the middle of this bad boy. So then if we turn him into a hole, then we can use him to cut out things like that. So let me just blast it. We can grab this guy, and we can grab our hole guy, and we can merge them together. I created another one so that we don't have to worry about that. And then there we go. All of that just to get ourselves this little round thingy. Okay. So that is... Let me turn it into a hole so we can see inside it. Right, we still need to create plenty of space for the wires to go through. But this seems pretty structural, really simple. Yeah, unfortunately it is pretty simple. We also might have to worry about tolerances, so it should probably actually be slightly smaller. 26. Let me 13.5. There we go. Just a little bit of tolerance there. Okay, now we need to cut a hole out of this. So let's duplicate this guy, make him a little bit bigger, and then cut a hole. Now what I'm worried about is if we hit our wiring. Oh, that was not successful. I don't know what we did. Oh, we accidentally moved it up. That's the only issue. Okay, so did we hit our wiring? No, we did not. Okay, so I think that is promising. Right. We need to... Let me ungroup this, because we need to add something for the crystal to rest on. So I don't know, some kind of maybe not a cube. It's gonna be kind of ugly. Maybe like some kind of slope, a wedge. Let's rotate it, and let's go ahead and, how tall is this? 13.5. Move it up. 13.5. Let's make it a little bit smaller, to be honest. Move it over here. Is everything still supposed to be center aligned? I think everything is. So we can just center align everything. And get some kind of a shelf. Making sure it stays centered. Down. And we need to make it short. How exactly does the crystal attach? That is a good question. To be honest, I'm trying to think about that, because we have to have wires attached to the bottom of it, which is very unfortunate. So yeah, we can't just like glue it down onto something like we would like to. We have to somehow make sure that there's enough space on the bottom of it. So let me see. What can we do? Yeah, so like I'm not sure if we can even do something like this because the wires have to go through there, so it might not even be worth it. I guess we have to glue something to the back of the crystal, hopefully in a way that isn't super obvious. That might be our only way. Let me take a look at some of these other examples. I think they're just eating a bit of the bottom of the crystal, covering a bit of the bottom of the crystal, and then leaving it. So that might work. Let me see. What if we duplicate this bad boy again, and then we have some kind of a ring around the crystal. Let me see. Then we would need it to fit pretty tightly. So we would actually need to shrink this guy down to roughly the size of the crystal and have the ring be cut out. Let me see. This would then be solid. Like something like, not that. What did I, no. Go away. Go away. Okay, this would be solid. We would merge it with this. And then we have this structure in which the crystal would rest. Actually, I think we need to copy that, paste it in, and then we still need to have a little channel in which the crystal is. Let's see, So we still have a hole for the crystal, but then the crystal inside of the hole is also inside of this ring. Does something like that work? Right? Just making this transparent just so we can see what we're talking about. And then, yeah, that's basically what it would be like. So then we still have to make a path for the wires to go down into our channel, and then we have to make a path for the wires to come up. But then we have this little ring around the base of the crystal, which would be what it was glued into. So we have the wire, we solder the wires onto it, then we somehow shove the wires down and around. So we need to make like a curved channel there so it's easier, like you were suggesting earlier. And then we slide this into the ring and add some super glue around it, and boom, it stays in place. The main thing I think we're missing is I would like the crystal to be a little bit higher up. Yeah, exactly. I think it really won't be the best, but it'll be good enough. Let me ungroup this and then move the crystal. Can I grab this bad boy? And no, not you. And then we move both of these up just a little bit, just so that they're centered on the ring thing. And so there's a little bit more space behind them. I think it'll look more satisfying. Okay. And then we have to get rid of all of these things again. Okay. Now picture ding, ding, ding. Group. And with this hidden, that's what we're looking at. A little ring for the crystal to go in. Thinking about the 3D printability of this so far. If we were to print it standing up, then we just need to make sure that this angle thing gets built here and it'll be good. Fancy. Yeah, I mean, we're close to fancy. Yeah, it'll be, I think it'll work. Okay, so if we do end up doing some kind of angle thing here, then it should be 3D printable from that perspective, because the 3D printer can do an angle like that. That should be no problem. Then this area here, I'm picturing like this right here being the bottom. So this angle is no problem. This right here is pretty small, so I don't think it should pose too many issues. This, we have to somehow make it an angle, because a hard line like this, the 3D printer will not be able to do. But there's also going to be wiring hole here. Yeah, I'm not sure how we're going to get that to work. Yeah, how can we make that 3D printable? I guess if the hole here is at a diagonal, then that would be an angled surface, so that would be okay. And then we just need to make the top of this be just having a notch here is not good. I don't know. Maybe we have to print it lying down. I'm not sure. Let's do this part though. I don't think we want it to be an angle. It would be better if it was a curve. Can we do a curve? Let me see. Rotate it. That was 100 degrees, not 90. Okay, now let's go ahead and... How tall is this? Not the whole thing, just part of it. I think we need to ungroup this. So we're going to need to merge some of the components. Okay, so what height is this? 13.5. We move this up 13.5. 13.5. Okay, that... what? I guess there, oh, it sticks under the thing, so we need to make the upward movement 13.5 and not the actual total distance from the ground. That's fine. Okay. So we just need to kind of make this, is this the right curvature? I'm not sure. So what we need to do is... Is that ungroupable? No. This needs to become a hole, and then we're gonna cut out. We're not gonna cut out a hole in this. We're gonna create another object and then cut a hole out of it to sort of. It'll be easier if I just show it. We're gonna do what we did earlier for the hole, for this round thing. Okay, we cut the hole out of this shape. And then we turn this shape into a hole object, and we merge those two. And then that did not work the way I had planned for it to work. I think I messed up with the with this guy. Let's see. Yeah, he is not going far enough. Let me just make him extend super far. Group these together. Then maybe have the crystal holding ring extend to the back so it's all a cylinder. Have the... Oh, interesting. Let me make this a hole so I can see what we're talking about here. The problem is, let's see, that would work nicely for letting the wires go down through. It would, because we could just cut a hole there and then it would be hidden by the cylinder, which it would be good. My only concern is we have to figure out how to screw 3D printability. Let's just try that out. We just make the, wait, where is the rest of my thingy? I feel like I'm missing some of my pieces, like my crystal piece. Oh, I must have accidentally disappeared it. Okay. So we make this extend to here. Is that level? to here, precisely. And then, of course, we need to make a hole object that cuts a hole in this cylinder and also a hole in this. So with it like this, then we would be able to, let's see, make that a hole object just so we can see. Then we would be able to have the battery holder, hide that, group those and then hide them. Let's bring them back. Blast it. I just need to do some cleaning up here. Make this a hole. Combine it. Okay, let's just hide that. Maybe we should have just deleted it. Okay, so with this, we need to make it shorter, but I think this works because then the wires can still get from there and they just hide themselves in the cylinder. I think this is what you were suggesting, hopefully. And then we need to make a hole for the wires to get down there. That's going to be my main concern, is how are we going to get the wires through there is still a conundrum. Especially with this thing covering over them. Let me see. We do have a tiny bit more space if required. But also it probably doesn't really matter if we just cut this back a little bit. So we can have the wire go from there inside, but how do we route it? Yeah, I just feel like it's going to be really hard to force the wires through. Let me think. How can we do it? Yeah, I mean, so if we solder this, we will solder the wires to this battery holder first, then we can, this area won't be, it won't be tight here because we'll just be pushing them in, from without the battery holder being in place. So we can just move the whole thing. So I guess if we can figure out how to make it a nice curved path, then theoretically it would be fine. I don't know what to do about this, because currently, if we take a look at this, if we merge these two just for a moment, we have this massive shelf, which is not going to be strong at all. Oh, but we don't need that. We only need this on the sides, right? We can have the wires just go along the sides there. We don't need to have this cut through. That's silly. Yeah, we can just do that, right? Because then the wires, just go, they come up here somewhere. We'll figure that out in a moment. And then they just go down the sides to the Profi board. That's where they need to go. Or they go up to the buttons, either way. Yeah, I don't know why we had that cutting through the middle there. That would be pretty bad. Okay. Let me see. In which case, actually, we don't even need whole objects here. That's just silly. Because we just have space here. Okay, so how on earth do the wires come up and go down? How do they go down into there? And how do they come up into here? Well, let me turn this into a hole so I can see the inside. So we need them to go down to there and then up to here. I think there's probably some kind of curve object, not like a curve like this, but yeah, like a tube like this. I think this is what we need. Let me increase the sides. For the dimensions, we might just have to eyeball it. I don't know. These I don't think I've worked with one of these before. Looks like it will work. Yeah, I think if we just cut out the right segment of it, and as long as it's roughly the right where is my alignment? There we go. As long as it's roughly the right thickness, then we should be in good shape. Okay, so let's align it there. Wow, somehow it's actually just providentially like the right thickness. Don't move like that. There we go. Oh, okay, it needs to be a little bit thicker. Wall thickness. There we go. Now we're talking. That looks about right. Okay, so now we need to just cut this guy down to be just that quarter circle. I think that's right. Let's duplicate that. Give it a cut here as well. Let's just guess that those are in the right place. See what happens. Not too bad, I don't think. Let me see. I think we need to move that one back because this doesn't quite align. Also, it is slightly too wide. That's something we can adjust though. If we just turn our snapping down a little bit, then probably. Then we can get it to be exact. Okay, maybe we just turn our snapping off altogether. Now the bottom, okay, we just need to move it down slightly because the bottom and top are both incorrectly offset. Oh, I think that actually lines up. It's just a little bit too tall. I don't know if we can fix that or not. Okay, I think we ungroup this for a second and move this guy up a bit so that we can actually get the, we should probably turn snapping back on. Move this guy up a little bit so that we can actually have the hole actually come out and punch a hole in the surface. Excellent. Okay, so now yeah, then we can, I think, just make this guy not stick out as far. I think that shouldn't cause any issues. And then this becomes a hole, possibly, well, maybe we make it a solid and we make this a solid and we merge them together. Well, maybe we duplicate this curve guy and then put him at the other end as well. 10.01, 10.01. And then we move him down to the right position. We do not move him at all there. I don't know why it's 29.99, but it looks correct, so let's try merging these, and if it works, that's gonna be pretty sick. Then we make this solid, combine it with this new shape that we've constructed, and then maybe, just maybe, oh, well, our curve does not come up high enough on that end. So let's just take a look at what it looks like. Oh, it does come up high enough, but it's too far over. So we need to ungroup this guy. Let's make this guy so we can see through him. Now this needs to be Yeah, almost perfect. We just need to move this back a little bit, and then I think it will work nicely. Need to make this not move sideways at all. Okay, is that right? Or should we move it one more? I think we should move it. Let's try it this way. Not sure which would be easier. If it would be easier if it's like right on the edge like that, or if it would be easier if it was like the full width, because obviously we're losing a little bit if it's on the edge like that. Okay, make them whole, and then make this solid, merge it together. Bang. Let me see, let me make him a whole object for a second. Okay, so that's currently what we're looking at here. The wires would come off of the end of this guy, because that's where the positive wire is, or maybe it's the negative, depending on which way the battery is. And then it just goes down into the curved thing, and theoretically, the fact that it's a curved... Uh-oh. Okay, good thing we looked down here, because there's a very thin thing that we need to fix. But aside from that, then it goes down the curved channel, then it comes up the curved channel on the other side, and everyone is happy. Okay, let's fix this little issue that we had here. Ungroup them. We need to turn off snapping, I think, because the issue is that it's just very slightly, it needs to overlap very slightly more. Good. Select all three of them, make them whole objects. I guess actually just group them together, then make them a whole object. Grab this guy, make him solid, grab this guy, combine. Okay, now it's actually possible for the wires to go down here. And once they go down here, boink, they just get to come up there. That is pretty good. I think that's good. Okay. And hopefully those curves, make it easy enough for us to actually be able to get those wires up. Now, we need to cut something out, because currently the Profi board is completely covered there. What else do we need to do? We obviously need to, make that actually just a cylinder inside of there. Yeah, so cut a space for the Profi board, make that a cylinder, and then we would need to do some more stuff down here to make sure that the battery holder actually gets stuck together. Are you sure there's enough space to run wires to the speaker? Good question. Let's show all of our things. Actually, let's just go ahead and merge this guy with this guy. Right, that's what we're supposed to do with him, isn't it? He is not aligned. I think that everything is still able to be center aligned, if I'm not mistaken. Okay, I guess that's a no. Somehow he got uncenter aligned. What's going on there? Is anything... Can anything not be center aligned? I think we should be able to center align everything so we can check on whether there's enough space. Yeah. Okay, so getting rid of... Wait, actually I want to show that. I want that guy back. That's the whole point. No. Okay, yeah. So I think that there is enough space to run wires to the speaker, because we have, we have this much space on each side. So I think that we can just run a wire along the side there. And I think that will be fine. We still need to figure out how to actually add enough structure to hold this guy in, probably extending this curved thing down while leaving a hole in it for the battery to fit in, for the battery holder to fit in. But I think there's enough space, yeah, on the sides there. That seems like plenty. We could maybe measure it. Just get a rough idea. Yeah, I mean, we've got almost 3 millimeters, and the wire is roughly 1.5, so we should be, yeah, we should be fine there. That's good. Let's see. I don't think that is of any use to us. I think we have to, we can delete that. Let's see. We need to make a hole for the Profi board. We also need to, I think, extend this. Could you add another ring on top of the crystal? Yeah, that could, I think that could even look good. Let's see. So, I don't know how deep this is. I kind of want to make this, split that, this, split it one more time, a little bit taller, so we have a little bit more freedom where to place the crystal. And then I think, yeah, we could definitely add another ring. How do I make the ring? Just like this, its own object, and then we can duplicate it, move it up. I should turn snapping back on so that we don't get crazy placement of these. Minus 15. And then we make it super skinny. And so then we just have to figure out where along here to place it, but I think that could look fine. The only question is, can we still get the crystal in if we do that? Because to be honest, yeah, I don't know how much. Maybe we just put it a little bit further down, then it should be easier to get it in. Yeah, we can probably smush it in, right? Actually, should this be a hard line here? Maybe this should be an angle. I don't know if we can even pull that off, but maybe we could. Let's see. We split this, yeah, then we make this solid for a moment. We add a slope. Rotate it so that it's facing like this. Make it much smaller. And then hopefully we can just cut an angle out of this guy. Something like that. See if that works. There we go. I think we cut off a little bit too much. Did we cut off a little bit too much? Honestly, we cut off a little, yeah, a little bit too much, yeah. So I think we just want to pull this guy back, so he's cutting it more like that, if that looks fine. Whole group, just to make the top angled so it looks a little bit better. Oh, something is wrong here. What on earth? Maybe we are cutting, but we're not going down far enough. Let's see if that does it. No. Make him a hole and then merge. There we go. Nice angle. That will hopefully help us slide it in. Okay. And also potentially help with printing. This may be an issue for printing, so we may have to remove it, but for now, I think it looks good. Yeah, okay. Now this guy, what happens if we extend him? It stretches. That is unfortunate. So we need to split him back so that we can extend this. Pretty far. I think all the way to the speaker, honestly. Yeah, that's good. And then, can the 3D printer bring a ring that thin? Let me check how thick or thin it is. The main thing, yeah, I can check. It can probably, but probably not if it's standing up like this. Like if it was lying like this, I suspect that it could. Wait, can I click on it? Nope. How wide? I need to know how wide it is. Yeah, it's 1.35 millimeters. So if it was lying down like this, the 3D printer definitely could print it. But if it's standing up, yeah, well, I can't make it stand up for some reason. But if it was standing up like that, then there's no supports here, so it would not. Unless we added some kind of supports, then this ring would not be able to float on its own. If we were trying to print it like standing up like that. Okay. So for now we'll leave it, but yeah, like I said, we might not be able to, depending. Okay, so then can still combine those. This, we need to make a cutout for the battery holder. So let's go ahead and make this slightly bigger so that we have some tolerance. How much? Let me say 21. Transform it into a hole, and then grab these three, and then bang. Okay, I think that's more tolerance than we need. It's definitely more like this way, because obviously there's a lot of extra space there. It might actually be reasonable on the sides there. It might be a reasonable amount of tolerance. But yeah, long ways, it's not a reasonable amount of tolerance, so we can rein it in a little bit. Yeah, that should be good. And I guess this should apply to, we don't need this to be such a refined shape. We can have it be just a square. And then this should apply to this guy as well. We definitely want to cut him out. So let's grab him, that guy, and her, and then we merge them together. And there we go. We can slot in the battery casing here. Then the wires go down. Oh, we need to merge in this. And we can actually merge it with this guy too. And, okay. So we have the wiring channel. They can go down there, come up here. We have this crystal holder. I'm not sure if we can cover that much of the bottom. Can we? Let me take a look at this pinout. Okay, we actually can, because if you look at the pinout, the top three are power, D-in, and 5 volt, and then the bottom three are, we don't need the bottom three. I'm guessing it's another ground and another 5 volt, and then D out. So we only need one 5 volt, one ground, and one D in. So we could cover up to the whole bottom half of the crystal, and we would be fine. So having this here should be fine. We have space for the battery holder to be put in place. This guy can be glued on to the end of this whole thing. I think we're in really good shape. We need to cut out something here still. And we need to make this guy cut out as well. Let me just do that right quick. He's not centered, dang it. I don't understand why he's not centered. Now we grab him, Show hidden items, grab this guy. Oh, this guy's not centered. Is that gonna be an issue? Yeah, for some reason that's an issue. I don't know why. Why? Oh, I see the problem. We never made this hole, and this guy didn't ever get centered. So we gotta fix that. Let's ungroup him. Then we select everything and center it. Bang. Then this guy stays solid because we have to merge with the holes. Merge that up. Then we transform him into a hole and merge him with this red cube. Why can I not enter? There we go. And there we go. And then we can even, well, we need to make the red cube a little bit smaller for tolerance purposes. What? That is not the red cube. Alright, let's hide these because we don't really need them at the moment. Make this red cube a little bit smaller for tolerance purposes. There we go. It was 27.6, so let's just make it 26.6. And then we can just combine it with the rest of the chassis and bang. Is that... I think that we might as well add some... make sure there's enough space for the Profi board. There's no need to like crunch it on like that. Okay. Still missing a diagonal for the Profi board so that we can access those. So we probably need to make a cutout there, but... Also, we need to mark the button placements somehow because we spent all that time figuring out where to place the buttons, and we need to make sure that they actually get placed in the right spot. Could you glue the board? Yeah, I think that's what we'll have to do. If that's just a good idea, we'll just have to go ahead and do that. Hi, Diamond. What's up, man? Okay, so. Yeah, I think we're just about completed. We just need to make sure that we can actually access the Profi board. And then we should be good to go. So we just need to make, we need to ungroup this a little bit. And then we can make a little triangle angled cutout. That should allow us. Well, we're trying. Definitely getting a lot of help from chat because I'm not the greatest 3D modeler in the world. But these guys have been helping a lot. Okay, let's see. Let me turn this into a hole so I can see what's going on. We need... Okay, this might... We're definitely... I think we're going to collide with the wiring. The wiring hole is going to collide with this. Is that a problem? Honestly, probably not. It's probably for the best. Because if the wires come into here and then we shove them up there, that's probably a good thing. Yeah, that should be good. I might... Let me see. Modify the wiring path just to move it back a little bit, just so that it doesn't collide as much, so that there's still space for the wires, even with the SD card. Let me just take a look. Oh, okay, that's definitely not going to work since we just cut the chassis in half. Okay, we want to move this down a good bit. Let's see if that's more reasonable. Okay, no, there's no way we're getting the SD card out with it like that. Let's see, we just need to find the right balance. No, that's still not good. I guess we just extend this guy outward until the SD card can come out. How the frick do we get this man out? Let me see. I think if we... Hang on. Yeah, so the problem with this is that it makes that like not attached very much, but if we were to just chop it off, could you angle the SD down? Oh, that's true. Wait, actually, we could just angle the whole Profi board. That's actually brilliant. There's no reason, yeah, there's no reason we actually can't do this. We can just make it like something more like that. That'll be way better. Dude, that's perfect. Okay, I need to change the settings so I can go in between. Well, that could be a problem. How do I go in between? Oh, I can just type in a number. That'll be fine. Well, let's try it at the... No, I think that's going to be too weak if we put out that much. Oh, yeah, Shade. Yeah, hi, Shade. I remember you. 12.5. Then if we merge this, then we're we're a little bit better. We can move it back a little bit more even. And it should be good. Let's see. Let's take a look. Can we get that merged? Okay, I merged it with the wrong thing. That looks pretty promising. What do you guys think? You think we can get the SD card out with it like that? I mean, we might need to cut some off of there. Hang on. Let me see. How do we do this? We add a cube onto here. Make this a little bit wider, and then we'll use this to cut some out of the triangle. Is it possible to make a 100% accurate working lightsaber using weird physics? I don't know. I think the problem is that we don't have it's hard to shape like plasma. But I mean, if you look at Hacksmith, they've seemingly come pretty close. Like the Hacksmith Industries YouTube channel, if you don't know what I'm talking about there, they make almost real lightsabers. Let me see. I think this is pretty promising. Not sure if this will be structural enough here. It seems a bit weak. That is my main concern at the moment. Yeah, their channel's pretty sick. One day we will be like them. Let me split this open. Yeah, perhaps not. Let's dive in here. Okay, we just need to shorten this channel a little bit, I think. Move it to... snaps in that direction, and then we need to not move it in that direction at all. There we go. Let's see if that's... yeah, that should be good. Then there should be no collision between the wiring channel and the cutout. Maybe curve the wiring channel less? Maybe. Yeah, I'm not sure. To be honest, I think you're right, but I'm not sure how, because... let's let's see, we have this curve. I'm not sure how to modify it so that it curves less. Without, you know, just making it a straight line, which I don't think would be good. How could we do it? Also, this just seems like it's gonna be weak. But if we put it like this, I'm not sure if we can get the SD card out. It's a tough call. We could angle the board slightly more, possibly. I just don't want this up here to end up too thin. Let me see. Let me ungroup this, and we can actually make a cutout for the board, because currently it's overlapping. I guess we pull that up, and we duplicate this, and we angle it the same amount as we angled the board. How much did we angle the board? I do not remember now. Maybe 20, 10, 15? Yeah, we must have done 15. Okay, and then with that, we can just stretch it like that, and then dink, dink. And there we go. Now it has something to rest on. We can pull the end back in a little bit. And then I think that's pretty good there. Now the Profi board isn't clipping anymore. Let's see what happens with this merge. I don't know. Looks pretty good. We might take another look at the wiring channel, so I haven't merged it yet. But I think, yeah, we just glue the Profi board on there. Oh wait, is it sticking out? It looks like it's pretty close. We should definitely check. No, it is in. It is in. Nice. Also, let's make sure there's enough tolerance on this guy here. Okay, there's more tolerance on the top of him for some reason, so I should probably fix that. Let's ungroup this, and then make sure that, oops, make sure that he is moved up slightly, maybe 0.25. Okay, let's, yeah. Okay, I think that's more centered. Hopefully I am right, and didn't just like mess it up. Okay. So the Profi board sits on there, then we can just go ahead and merge that in. I'm not sure if we'll be able to get it to work, but it seems a decent chance. Yeah, I think it'll work. And I think there's definitely enough space for it to be plugged in well. There's enough space for it to be plugged in while we're not in the hilt. Oh, and there is when we take that out, because that's just up against. So yeah, we unscrew that, we can plug it in. That's actually, dude, tilting that was actually perfect. That's excellent work, Saffron. Yeah, no, I think this is really good. So what else do we need to do? Possibly take a look at the wiring channel. I honestly, I don't know if we want to curve it less though, because if we were to curve it softer, then it would come closer and closer to here, which we probably don't want from a structural perspective. Hopefully, let me turn this into whole mode so we can see how thick that is. Okay, that's a pretty thick gap. We could move it okay, that's kind of weird there. Gotta try to fix that. But we also want to, I think, move the wiring channel just a little bit, down a little bit more, because why not? Well, Yeah. I think it's probably okay to. I mean, the why not would be because we don't want to see the ugly wires. We want to see the beautiful crystal chamber, but yeah, we also need to figure out how we can make the crystal chamber look better, because it is looking sparse. This is definitely a good base, though. It seems like it's highly functional. We just need to ideally make the crystal chamber look a little bit better. But yeah, I think this would straight up work if we printed it. Oh, we need to do something for the buttons so that we know where to put them. And honestly, to keep there from being as much stress on them, we can just put some like little blocks down in between. I think that would be good. That'll give us more surface to glue on them onto. 10.5. Perfect. I think we just make this the same width if we can. Okay, I don't know what's going on there. We're gonna have to turn off snapping to get that fixed. Hopefully that fixes things. Let's turn snapping back on. Yeah, so I think just something like that will allow it to be glued in easier. Is there a cutout around the board, around the Profi board? There is like a diagonal cut, so that we can glue it onto there. Do we need anything else? We have access there, like there's paths for the wires to go through, and we have access to these things, so I think that should be good, right? And then it's just getting glued on there or something like that. Perfect. Okay, and then last but not least, let's not move it side to side. How much do we want to move it? It needs to be a little bit more. Let's make it 10.5. Okay, let's make it 10. And then let's just go ahead and make this line up with the end there. Perfect. So there we go. Now we'll know where to put the buttons. I'm not going to put anything beside them because their leads will stick out here and here, and the same on the other side. What just happened? So yeah, we need to have space for their leads to stick out. But honestly, I think we might be done. If we're missing anything, someone give me a shout out. But I think that we are in good shape, to be honest. Just gonna extend these downward just to make sure, because we seem to be having some wonky things happening with the edges, and I want to make sure they're all considered one united piece. Blast, it did not help. Looks great. That's good news. Okay, so yeah, I mean, I would like to do something to pretty up the crystal chamber at some point, but functionally I think we're good. We drop in the battery casing and its wires go, well, one of them goes to the LED and the other ones go down into the wiring path. Then the wiring path wires come out to go to the board. There can be wires between the board and the buttons. Oh! This is very important. We need wires to go to the LEDs. Currently, there's no path through at all. That is good. That's good that we noticed that. Yes, it is slightly important that we actually have wires going to the LEDs. We need 3 wires to go through, power, ground, and 1 data wire. Yeah, so I think we just cut a hole in this chunky guy right here, and then I think we'll be in good shape for our test print. Okay. So we discovered that our wires were 1.5 millimeters, so 3 wires would be 4.5 millimeters. Let's go a little bit excessive and say 7. And then let's just make it 3 millimeters wide, so it's double wide, and see if we can fit that in. And that does look like it'll fit. I just want to find a good little spot for it. No, move to the side if I can get it to. I don't want it to overlap too much. How much does it overlap? A little bit. Let me just make it a little bit wider since it's overlapping a little bit. 3.25. Okay, that will be our hole. Actually, we need it to end up in the center, so we might have to angle it. Because we need our wires. It gets a little bit narrower, so we just want to make sure that they are ending up in the center. Where is that? A little bit over. Okay, that should be good, and that is pretty central. I think that's central enough. Maybe it should tilt down a little bit. Actually, we could just move it down a little bit. There we go. There we go. I think we put 3. Let me group it up and see, but I think if we put 3 wires through there, that would be central enough that it goes into the. It's able to go through into the center. Let me see. Just in case, I just want to grab this and maybe make a little bit of a buffer. Let's see. There we go. Now, how deep do we want this to go? Oops. We want to grab onto this. Make it go in just a little bit. And then there we go. So if the wires don't end up close enough to the center, then we can just reroute them in that little area there. All right, I think that is a good night's work. Yeah, I mean, we've got. Yeah, now it is looking good. I mean, maybe we'll come up with something when we test print it or do a dry fit. But to be honest, the Profi board there, I think those are accessible. We've got the buttons, we've got wires going to the LEDs, to the battery, to the speaker, everywhere. We've got the crystal chamber. I think it's looking quite good. We've even got our little secret wiring path down here. And the wiring path is messed up, and that's good. I'm glad I checked, because it definitely seems to like getting messed up. Okay, so we need to ungroup this probably a couple times, to be honest, to just fix this little bug here. Oh, we gotta ungroup it a lot of times. Okay, and we can ungroup this. Turn off snap. I wanted to go 0.1. There we go. Okay. I think that is just about it. We have ourselves a chassis. Oops. Are there two of those? Oh, well, there you go. Now there's only one. Yep, that's all that needs to be merged, except for these two. There we go. Okay, so we have ourselves a chassis that supports the buttons, the battery, the speaker, everything, the crystal. Oh, well, I guess the crystal got lost somewhere along the way, but we still have a chamber for it, so I think we're good to go. I think that's going to be about it for the stream. Thanks everyone for all the help. This would not have been possible without you guys, for sure. I'm just gonna say that. Yeah, I will drop this in the description before I forget. I think I have to change some kind of permission settings or something like that. Yeah, there we go. Copy link. People with this link can view and make oh no, I don't want to make changes. I trust you guys, but not that much. I think meh, I'll figure it out. It'll be in the description. You guys can check it out if you want. Thanks for all the help, guys. I think that's gonna be it.